I was just googling a bit buffer overflow here, and this is given a few links. One of them is text. Here's an Hasred video too. I just saw it is. It's a stream, I guess, from 3 years ago. So that's not like what we'll watch on stream. But if you are interested, I'll probably watch later too. This one is text, so we'll probably do that one. It also said like it might make your brain hurt, but you'll learn a lot. That's kind of what I want, you know. Not for my brain to hurt, but a lot of information. So let's see. Go to source. More advanced resources are a good thing. Most things like assume we stopped implementing exploit mitigation 99. Then you confused. This doesn't mean you probably find challenges very difficult. So there's challenges in there. I will look at this page too. So this might be when after the other thing, right? So we need to get a lot of information because yeah, so I don't feel comfortable with the tiny bit of information that we got from those rooms, and the only rooms that I found on TryHackMe that were straight to, you know, exit 6 assembly. I already done those, you know, and they're extremely basic compared to what we were. It's mostly that I don't just want to do what they say, you know. I want to know exactly how it works, because otherwise I have not really learned it, right? So that's... oh, sorry for minimizing stuff here. So... course... okay. Yeah, so I already have this link, I think. So this is probably YouTube playlist, right? Yeah, so we already have this YouTube playlist up. But I'm not going to... well, let's close it again since I know I have it up already. Let's actually make like a... I didn't have it up, so it's probably put it down in my number 7 here since stream crashed yesterday. Reading. Smashing the stack article. Right, so let's do that. Basic financial understanding of how the stack works and how we can exploit it. Having knowledge of C++, yeah. But we want to know all the assembler stuff too, right? Because it's not like I haven't used it, it's just that it was long ago, and lately tiny processors, which are much more limited. And nothing like this, right? Working knowledge at this. Once you have that down, you can start to challenges on this site. Okay, so is this connected? No. A lot of links. It's also warm in here, and I feel a bit sick, so we'll see what this ends up being. So I opened the window, and I hope I won't be coughing too much. Maybe I should get some tea or something. We'll see. Yeah, so didn't go to work today. I slept a bit extra instead. But not much actually. Just off. I feel off. This is a good walkthrough. Another YouTube video. Started Python in general. Okay, so I know the basically both. So yeah, they're like Making art was a pretty chunky book. Yeah, so book. So you could probably like find it, download it, and listen to it while doing other stuff. I'll just say the name. I should probably do it in my. So I couldn't drag past this with selecting. It was funny. So we have a tiny notepad now there to do something with later. Yeah, so this was just a random. What's this? Because Reddit is not like my favorite place. But this might be interesting. Whatever. Let's close it. I just googled there. This was like the first one, and there's obviously more. Let's check a few more resources so we can like choose what's the best. How people learned. And this is an OSCP, and this was in the Osknetsek. And now it's Netsek students. There seem to be a lot of these. But for Overflow basics. So we want maybe not basics, maybe details, you know? So we know what we're really doing, what we're supposed to do. I'm thinking this was a pretty video. Whose video is this? Let's click that one too. Beginner's Guide. What is? Let's check the links we have now. Was this the same video? No. So why is this purple? I probably clicked a lot of stuff. Yeah, so I'm kind of thinking from scratch. Yeah, so I'm thinking most Medium articles and stuff will be like, this is what it is, and not like, this is how the details actually work, and all the things, you know? But let's start with what I found first, because I started looking at TryHackMe, and I did find things. I did search on TryHackMe for different things, and in these, you know, Advent of Cybers, this is the first one apparently. It's hard to see what they are, right? Well, some are kind of obvious. Yeah. But this one, I clicked it, and I clicked this materials, and this document. We found gold. We found gold here. It is like great, and let's start with this and transfer the things here that are nice and interesting to our notes. And the notes are public, so it's in my notes, it's in your notes, right? I'm opening the notes, and I did also add here, I found yesterday when I was searching, that if we do GCC S, we compile to assembler, so we can get it in assembler form, so we can learn assembler better than this one too. So I just put it in this old note I had here. Maybe I should just check what these images are. This is really blurry too. This is just too big for the quality of the image. So let's try and make it a bit. That's not readable either. So since I can't really read even what it says GMP, I think. I can't read it. Really, I can't read it. Oh, that's a bad image. Oh, you must say push from just, right? It must be push. So really, this image is horrible, right? We need to, if we're supposed to have this in here. And this is also calling convention, and I don't know where, you know, how it's connected. Also, let's check this one that someone sent me. This is actually lessons. I was more like assuming it was like with a wire that you had like challenges to, and this is just extremely basic lessons. So I'm thinking we won't go through and do this. We've already done a bit of it, like not in here, but you know, what I was looking for now is how to call external functions like printf. That's what I was going for. And we can just do this by compiling it to ASM and see what it looks like there, hopefully. Oh, sorry, the mic. And my voice is, you know, as it is today. So I will probably be using TDS a bit too. Closing that for now. I'm not disregarding it in any way. I googled there for call printf, and I didn't really get the good hits, right? So we're on Microsoft, meaning yeah, so they're running assembler inside C. Char format, char hello, char world. And then they're using hello world and format. EAX push. EAX push. Oh. Yeah, this is a different way of putting them. That's what we were seeing yesterday too. Push. And then they have to pop them again. I think the other way is better than this way. This is ugly, kind of ugly code to me. Anyway, they put the 3. So we put them in registers instead of on the stack. Right? But I guess if we have a lot of stuff. Clean up the stack. Yeah. Let's close this one. Anyway, all the things here that we watch is learning. I haven't watched any of this. It was just Google hits. Let's put these in the number 7 here. You know that we have a lot of other stuff here that's interesting. That I closed down yesterday after the crash. Yeah, I started looking at this and it wasn't really saying a lot. But it's a long lecture here. So let's keep this up since I started watching it. And this was just what this was a part of. It's this one here. Yeah, so I'm sure all of this is interesting, but we can't like spend hours and hours. And YouTube videos are not good on stream. Let's close that. I was just checking for yesterday. There was an interesting. Actually, I had it up here. I think on anti-siphon. It's here. So this one I'm going to watch. I should have watched it yesterday, but I was streaming when this was, so I missed it. Should have stopped streaming 1 hour earlier and could have raided them instead, because they're streaming it on Twitch too, you know? Yeah. So I want to watch this. It's just an hour or two later. Then this is something, a link. Let's just randomly go through stuff. We'll see where we end up. And also I have that we wrote down yesterday. We need a fix for YouTube chat. You don't have the same stuff as Twitch has. And that's, you know, we need equal rights here, right? Pratchett's reference, definitely, right? Locksmith, a tiny and small tool built to find common misconfiguration. Oh, right, so these are links from this one that I shut down. Right. Yeah. I think all of them are. All of them are. Let's just pop them just after this one here. So, because I got these from the Discord. So, let's see. I don't have Discord up. Making sure I'm saving resources. We should put this notepad thing in the notes too. So all of my browser stuff is really on the other side here now. So let's just select all of the million tabs I have and move them over here. So here. So this one that I mentioned with the document. So I don't think that this task is anything really worth looking at, but if you read here, you can see that these are the kind of things we would like to, you know, look at. What's the value of local CH when its corresponding mobile instruction is called? You know, so they're looking at the details of the code. And I started reading this one, and it's great. It's great. I think we can close this one down though, because I think answering questions on the files they're sending. Yeah, maybe we want to do this. Supporting material here. Let's see, is this the same file? I'm kinda assuming, but it might not be. No? So these have all supporting materials. We're not closing this one down. Yeah, I'm like, oh great, resources. I want all the knowledge. And then we have SQLi here. So I'm assuming we're not at that low level anymore. But now we're hopped. Let's see. Facebook messages including... So we want to check the low level stuff now, not... Well, we'll see. So this is long before I started looking at this stuff, you know? So I did a bit of last year's, but then I got annoyed at the not being enough details. So I want all the details. So Rolf reverse elfineering is the one that we found the first note on. Now I almost have to check if there are other notes on these. No, this one didn't have one. I didn't really look here. So, supporting materials. All of these supporting materials, I'm like, we need to check these out, right? It's hopefully as great notes as I found. So here they have supporting materials for Hydra. Oh, that's a blog article. And this is I Google Doc again. So you could never find these documents just randomly, right? So let's just look at. Okay, so this one doesn't exist. That's not the best thing. And this is Python scripting, and this is nothing to see. So the blog ones, they don't exist. We should tell them, right? Yeah, I'll read these later. Command injection. You know, these are like notes on stuff. Are we now getting great notes on Amazon Web Services? Because I think now they're just putting them in there, you know. Insecure cloud storage. Of course, from 2019. So I'm kind of thinking I won't open all of these up, right? Let's just see quickly. So let's go for what we're really interested in now. XSS. So if this is just Python scripting, I will just make a note that in my head that we looked this. Yeah, so this might be interesting. Let's leave that one up then. So starting with this one, and this, we'll see what this is too. I'm kind of thinking it will have less and less connection. Elf encryption. So it's just some general. It's just elf because it's Christmas stuff, right? Yeah, so that was just normal encryption. Might as well check. I could read that later. Let's actually. I don't want to assume I know all the things, you know? I want to learn all the things. We skip Metasploit. Is this more basic Python? Yeah. Yeah, so I think I might just do this sometime, you know, all of it. But let's focus on the stuff we want now. Okay, reading files. Oh, that was XF2. Yeah, we can skip that one too. I'm sweaty. It's warm in here. So let's just see.
Connected to channel Fix at 42.
Oh.
Fixerbot says.
Connected.
T-4 minutes.
Sorry.
Stream about to start. 1 minute left.
Sorry. I'm just checking that I'm actually streaming here. So I'm actually a bit amazed that people watch the streams, you know? After the stream has ended, people seem to hop in and watch stuff. That's good, I guess. Someone like what I do. But I was thinking of uploading the highlights, really. That's like better. Since I won't read all of this aloud since I'm my code. Maybe even do this bit. And here's where R2 download. I don't think that's current. And we have R2 in Kali, so we don't need it. Oh right, so we can't just select a bit and TTS it. Maybe we can, using the button. So I will start this TTS and I will go and get some tea and refill my water. Meanwhile, so just the first bit really.
x86-64 assembly computers execute machine code, which is encoded as bytes, to carry out tasks on a computer. Since different computers have different processors, the machine code executed on these computers is specific to the processor. In this case, we'll be looking at the Intel x86-64 instruction set architecture, which is most commonly found today. Machine code is usually represented by a more readable form of the code called assembly code. This machine code is usually produced by a compiler, which takes the source code of a file, and after going through some intermediate stages, produces machine code that can be executed by a computer. Without going into too much detail, Intel first started out by building 16-bit instruction set, followed by 32-bit, after which they finally created 64-bit. All these instruction sets have been created for backward compatibility, so code compiled for 32-bit architecture will run on 64-bit machines. As mentioned earlier, before an executable file is produced, the source code is first compiled into assembly.s files, after which the assembler converts it into an object program.o files, and operations with a linker finally make it an executable. The best way to actually start explaining assembly is by diving in. We'll be using RaiderA2 to do this. RaiderA2 is a framework for reverse engineering and analyzing binaries. It can be used to disassemble binaries, translate machine code to assembly, which is actually readable, and debug said binaries, by allowing a user to step through the execution and view the state of the program. Download R2 from here. The first step is to execute the program intro by running /file1. The above program shows that there are 3 variables, A, B, C, where C is the sum of A and B. Time to see what's happening under the hood. Run the command r2d/file1. This will open the binary in debugging mode. Once the binary is open, one of the first things to do is ask R2 to analyze the program, and this can be done by typing in A, which is the most common analysis command.
Ouch.
It analyzes all symbols and entry points in the executable.
Right, so I was just thinking the first bit there, and then we're going to read more carefully. So, oh, I'm getting a headache too. Nah, I don't wanna. So, right, let's see what it does here. It does. The buffer shows that we have 3 variables. Yeah, so D. I don't think we do that, do we? Maybe we do. So we did a lot of is it GDB, right? And we have this old note here from me getting strings from it. But we need more notes here. Why did I close the other note? Oh my goodness. Nothing there. Okie dokie. So let's open the GDB notes too. Because here we just started with a command. So we just do GDB like my exec, right? Double. So, and then we get a prompt and we do lots of commands. I know that we get a prompt too in here. And when I used it, I did the A, which apparently is AAA when you get to the prompt, so you don't have to do that. And then we have now the suggestions of doing D, lowercase d, And this is from 2019, we have to remember. Debug the executable file or running process. We can also do a running process. That's kind of cool, right? So my tea is beeping. I'll go and get it. So I heard my kid coughing and I asked him, "Oh, are you coughing?" He's like, "No." Very definitely not no. A big no. Oh well. Yeah, so I really feel out of shape, but I'll just, time still passes the same speed, right? Whether I'm streaming or not. I still want to do this. I was thinking, should I not stream today? Well, I'll still be doing this, so why not stream it, right? So, the first step. So I was actually this morning. I was actually like playing a mobile game for like 2 hours or something, just relaxing in that. Taking it easy. So I've been doing that. Now it's time to continue stuff, right?
VR Mechatronics says,
Hi.
Hello, how is going?
Yeah, I found this nice document from TryHackMe. It's from the 2019.
What brand TTS voice you use?
This is Google's TTS, but it is. Let's open it up here. This is Security Live's TTS app on tts.bot, so it's free to Yeah. Right, yeah, it's poly. That's what it's called. The actual TTS in the background. You kind of notice when you set your voice. If you want to, you can do that. I think it's exclamation mark TTS. And that's what we need to add also to... Well, not exactly that command, of course, for YouTube, but... yes, I have my mic closer than usual. Maybe that's good. I don't have to be so loud. So we just TTS this bit, and we're going to the actual stuff there. Well, let's see. Maybe I should actually like move this over.
I'm just trying to use GTTS with Python and it's very unnatural, and your TTS is different, better.
Yeah. So you can get a lot of free poly from just registering, and yeah. I want to focus a bit on this now, so I might show you later. So I'm a bit sick today, so I'm taking it a bit easy. So let's actually remove that so we can do this kind of thing. So let's get all the information we can from this document, and then we continue getting stuff from other documents. Run the command r2d file1 is their suggestion here. So to debug, it also said, we confirmed it in the help here, to debug also it says file or running process, right? File or running process. And let's put it in this. And let's just make it the same, you know. We should start R2, right? I'll start the VM. I was thinking a bit that we should save resources, but whatever, you know. We need to get this started and test stuff. If we don't test stuff, yeah, the crash also made my VMware behave in odd ways, like white around the edges and stuff when I removed maximize mode. Actually, I can see like text on top here, though it's maximized. It's kind of funny. Oh well, let's start Kali. So right, we also need to there so I can see what you see. Yeah, we need to run this to be able to see if it actually works, and what we can do after this to get information. This will open the binary in debugging mode. Once the binary is open, one of the first things to do is ask R2 to analyze the program. And this can be done by typing AA. Yeah, and what I did before was the AAA, the capital A here. So we need to get R2 to tell us all its commands too. I'll just log in here. Come on. I'm going to sneeze. So I'm actually going to start this room, I think, because then we have a file to test with. Why not, you know? So where is it? It's not one of these, because these are all my tests. And searching and having open paths. Yeah, so we need just a general one. TryHackMe. And this is the one we were doing. And this is not. This is Windows, right? So we want the other one, which is called Buffer Overflow. So let's move this one to the start here. So, come on, Firefox. There, we dropping it there, and it's actually staying this time. That's nice of it. Yeah, that is the one we're supposed to continue watching later, or I won't watch on stream. So there might be something interesting in there. We could watch it, I guess. I don't think they would mind. But it's like an hour. Even if we speed it up, it'll be at least half an hour. If there's anything interesting. So, yeah, we can open this one. Oh my, seriously. Oh. Well, let's get some tea. I got some honey and milk in the tea, so. So, VR, if you're still here, I could tell you a bit more about the TTS if you want to. Well, let's see. Yeah. I was just going to start the VPN. Slow today. Since I'm a bit sick. No stress, just relaxing and having a nice time learning stuff. So, I don't know if it's unfortunately, but I do remember the password. I guess it's the most basic password ever. This is funny. Seems like you're on a smaller screen on a mobile device. So it failed there. So now we know how they shake stuff out. Just the size of the window. Trying to be smart. That's good, I guess. I'm waiting for the IP. Yeah, and that's another thing to put on the list. We want YouTube chat on the screen, right? So we can just share it with the TTS now. Oh, we have an API. So 54. I'll try to just say actual useful stuff, not just my regular ramblings. So there's the one we're supposed to use. To read the secret there, we're supposed to get a shell through this one. So this is a good example, you know. And we might just solve it by mistake, you know, while making notes. To hop back over here, I'm just using this one to explore now. But we might just do it at the same time. This will open binary in debugging mode. So let's do this now. R2 is what's suggested in the room, I think, so it's will definitely be installed there. R2D. And then we have buffer overflow. What? If we do like help here. So to any char command to get detailed help. Nice. We want this in our help, or in our notes help, that is. So we have the help for the command here, but we want the other one here too. So we have the usage. Yeah, it's prettier here, right? With the green and everything. I wish I could transfer this. So we can use font tags. Do something to make it like make a translation script. But not now, of course. Pretty notes, that's important. Anyway, we can search in this easily. So I have a tiny fly in here. And one of my kids is afraid of tiny flies, so we'll see if I can catch it. So A, analysis. B, display or change block size. Compare. D, debugger commands. Yeah, we can just question mark anything here. Nice. Oh, so we can use it like a wildcard to get help too. So let's do a question mark, because I want to see what's the difference between A, B, B too. Analyze block. Analyze functions. So what if we do AF here now? It doesn't give us any output. That was print functions map. Function information needs addresses, but we have those now. So here it's name or address. So since I have the code from before for this, the C code. So we have only this buffer here and this one, and just copies it. And prints it there. Yeah, right, it's the argument. Well, that's why it does it. The string into the buffer. But it's just 2 functions. So what if we do AF main here? Nothing. No. So let's check the notes now. Right, so we have, let's actually add a parenthesis here because there. Oh, sorry for me being out of shape here. So this opens the binary in debugging mode. Once the binary is open, one of the first things to do is to start to analyze the program. So why AA and why not AAA? So that's the AF one. So A is alias for AAI. So what if we do A first here? We get a basic information. There's one string, there's xrefs 116, calls 14. Yeah. So yesterday when we were looking at with my god, Hydra, the name Hydra. We were looking at an executable that we just compiled, and we noticed how much else there was in there, you know. Though I knew there would be a bit, but when I saw that the file was actually 15K for a simple hello, it wasn't even hello world. It was actually almost 16K. And that's kind of amazingly big, right? And it was not like it had all the stuff in it either. I can feel my throat when I'm talking. So, well, we'll see how smart this is. Anyway, AA. Analyze all. AA0 to avoid sub renaming. There's not an AA here, so let's do AA now. Analyze all. So first of all, let's actually quit this. And I could have just entered both. And let's restart it, because, you know, we did other stuff first. And let's now do AA. And I think we got the same. It's just the same here and here. Invalid address. Well, this is not very helpful, right? So let's do. Well, let's actually quit it again, and let's run it with A. Well, let's do A and D. Dev brain, no such file or directory. So to make sure, yeah, we could do that too. So it's analyzed. What I know from before is that if we do IZ, we get the strings, right? That's the only thing I already have in my notes. And let me tell you the other one had more. So let's actually put here AAA for analyze, right? Same as a at prompt. At R2 prompt, right? So which makes this obviously be that we could do the IC, right? We don't need to say that. Did this give us anything? Not yet. But it's also 5 years old. Most common analysis command. It analyzes all symbols and enter points. And it doesn't anymore, I guess. The analysis in this case involves extraction function names, flow control information, and much more. R2 instructions are usually based on single characters, so it's easy to get more information about the commands. Question mark A. We already learned this, but we did not add it to our notes. Well, we did in this. So at
Panda Tongue says,
R2 prompt.
I read your title as learning ASMR.
What? Okay. It's a real learning assembler, you know. Let's see. Maybe that's the same thing. At RT prompt. So if we do IC, we yeah. So I'm a bit sick. That's why I did like not a serious, more like random stuff today. But maybe I'm just continuing it anyway. So I should.
I'm glad I
remember that.
came in and you're not breathing or eating into the mic, lol.
Oh my goodness. Yeah. List strings. So what else can we do? Let's actually see what I is. Here.
Hope you're feeling better soon, smile, smile.
Thank you, thank you. Get info about the open file. So let's hop over here and do I question mark and we will get all the information, right? No, only if I'm actually there to type. So
Madam Fabulous says,
GM.
good morning. So show info of the current file in JSON. So let's just do I then, I guess. In JSON. So this is a file format. So that's not good enough. I want to know more information. So the one I had before is IZ, strings in data sections. There's also an IZZ. Let's go to the top. List classes, method, and fields. IA. Okay, IA. So we got the previous information from just I, and then we got imports. str copy inputs is used, and here we have main, and here we have copy art. So now we know where they are and how to do this in here. This is called exports too. So let's go back up. I guess I should put this in the help too. Or rather, that's my notes. Help part of my notes. So the A bit. No, that's the AF bit. So A is here. So I'm actually going to, even though it's not a lot of color, it's very what, not a lot of color. It senses this. Ah, well, there might be a better one, right? Let's do the eye one now. And then we need also to have just pasting it there. So actually it's prettier green, but so import, export sections. There wasn't much more, right? So let's just, I don't have to scroll up now. I can just look at the right side. So I see no clauses, which we know already, but ID. What will ID give us? Oh. Stopped, it says. Did it actually? So I was thinking I was in my notes. So yeah, it was okay there. So did it go background? Yeah. So why did it say stopped? So let's go IE for entry point. So, and we have ID was what I was supposed to type, nothing. II is just imports. I capital I. Also, we get this information. IK to query. IL for libraries. So there's a lot of stuff here. I'm assuming we can, when we learn this, we can run it quickly, you know. So IM is memory allocation. And there's no memory allocated, so I am IR IR. There are so many. IS symbols. Okay. So yesterday we read about the .text and .bss and a lot of stuff here. And here we have the copy arg function again, and the main one here. And you can also see func, and this is also func. So all of the things we can see when we look in Ghidra. So we're supposed to be able to see the code here too. This is supposed to be able to make assembler from the, you know, that was in the text inside. Yeah, let's actually maybe look at the stuff there. First, I'm curious. So IV. Version about the file. Version information. Are there any try catch blocks? No, there are not. We knew that, of course. Yeah, so I think we're kind of like exhausted the possibility of I. So what about AF then? So that's supposed to be analyze functions. So I would like to see, like, let's, right, you're already on this side. So now let's look here. So once the program analysis is complete, you would want to know where to start analyzing from. Most programs have an entry point defined as mean. To find a list of the functions to run, AFL. So we just did AF, which would be kind of fun if AFL now works. Then we already had this function, so AFL is definitely something else. Let's actually go back here. Scroll down to AF. And we needed to do a question mark to find all the commands here. So that's what, you need to learn this. When it's a question mark, I should run it. So let's run it. So AF question mark, right? AF question mark, there. So now we get all the full list. Oh. So let's copy this bit too. Let's put it here. So now I can search in this for words, that I might wanna, like functions, if I'm interested in functions. Though it's not as pretty. It would be prettier if I were to, oh no, where's the edge of the program? Make it a bit bigger. Yeah, it's still easier to just do the help command, right? Cause kind of nice here. So it has a nice built-in help system, but it's not possible to search for stuff in all of the things, right? And we can't list all of it. So what if we did like yeah, I want to have all the commands. That's what I want. So if I do, I still get only a question mark. Oh, this was cute. The cute one. Can you see it? That was funny. I usually don't like ASCII art, but this one was genius. Oh. Yeah. So I'll just take a short check on the kids. got some kid food for one of my kids, and the other one will put something in the oven for. So some lasagna. Oh. So, time to continue. They're grabbing here though. That's nice to know that you can. If we had 1,000,000 ones. I'm curious if it actually works though. There's no main in this line. See here, there actually is a function at main. Let's examine the assembly code at main by running the command pdf at main. Okay. So we didn't look at p, but p itself we have here. Print current block. Yeah,
VR
we need
Mechatronics
to check
says,
P.
amazing, Poland is introducing 35-hour week, full-time work. What
Oh,
hours is in Sweden per week?
we're still at 40. 35 hours. Okay, nice. Yeah, so let's P question mark. Let's see what PD is. Disassemble. Oh. So let's do PD question mark. Print disassembling columns. So P. Well, it's printing a lot of stuff. It can be 64 encode decode. So since we know that PDF was what they did, disassemble function. Okay. So yeah, I guess disassemble function. I'm thinking, is there like a disassemble everything, you know? And then I'm thinking, when would we ever be really interested in that? So yeah, let's so I might just skip those SHs and they're kind of useless, right? We can still see strings this way. Ah, so PDF disassemble function. And their way to find the function was not the same we did. So no? What's up? Because it's on a new line. It broke it, apparently. So So that's what I was going to add in between. So no. Oh, so annoying. Can't it realize that's a stop and start? No, because 3 of them is this. Okay, okay. AFL. AFL to print functions. To list functions is better. It's all printing of stuff, right? To the symbol. Just a symbol. And let's change the syntax here. And this will list strings. And we can remove all the 2, right? It's kinda obvious. Here, list strings. So right, so let's continue. Let's actually test. We didn't test this, I know, but we want to do first AFL again and get this output, and then we want to do AFL pipe to grep main and C. And now we only got this. In their output they had some, like, all the things anyway. That's why I was like, why? Right, so if we have a lot of stuff, it could be nice to grep it too. But the other listing that we got before was like better. That's where we did this one. So IS was symbols. So we have main here and what it is. So I'm just reading this. There. And where was the first time we got it? It was here, exports, main. And this is the IA command. And the IA was show all info. So let's put IA in our notes. IA. Show all info. And let's just scroll up and to the very top here. And see, so we don't miss anything we used that was useful. So before we did the AAA, we didn't really get anything. AA got us like this other thing, and IA was what they said we should do in the 5-year-old TryHackMe thing. Q, Then I did AAA, which was what I had from my own old notes. It's the same as dash A. And it does a lot of things. And there's additional even to do AAAA if you want to. And here's the IC that I already had, and then we checked what else other I's we had. And that's where we found all of the I gave us that, IA gave us this. That we just added to the notes. IC gave nothing, and then I undid and happened to be in this Windows. Entry point, IE. That might be interesting, right? So let's add IE is entry point. That will always be there, right? And then I did II to list the imports. II, where that? IL, libraries, IM, memory. So if there is memory, that might be good to know, right? So, just that we don't have anything. Memory. So, should I entry space point there? So, IS for all the symbols. Yeah. I'm just adding it. IS. Oh. AFL, list functions. So we have two ways to see the functions there. And just a tiny amount of things we have tested. So AFL. And there we just have. Now we only get to this. Yes, love. Ska jag komma? Okay, so my kid's calling. So 400, 564. 400, 564. So what's this first one? P adder, V adder. So I'll go check what my kid wants. Ready, gubben? Vad är det som snackar? Snackade du på min dörr? Gjorde du det? So I'll just go fix some pancakes for my kid. Let's switch to this one for now. I'll just this will take like 5 minutes maximum. Hopefully 3, but I'm slow today. There, I'm back. So, lunch for my kid who just woke up a few hours ago. So, today it's tea with honey and milk and slow speed. So, yeah, right. So I was confirming that I didn't miss anything I tried that was useful and added to my notes. IV for version. I'm like, is this useful? We can look it up then. AF, and then I tried question mark, then we got the funny thing. I tried 2 question mark after an A. It still didn't give us all the things, but it gave us ACE 3 letters. Oh. So, AFL again. Just with grabbing, though I'm assuming we will have to have a long list to find this useful, right? But let's add it anyway to the list, right? Because it might be useful. This is just a simple, extremely simple program. I'm so sweaty. So this is kind of self-explanatory after this one, right? We don't need to write anything. So let's continue. Note that memory addresses may be different on your computer. I would kind of hope so, right? As seen here, there actually is a function at main. Let's examine the assembly code at main by running this command. And we added this to the notes, but we haven't actually run it yet, so it's time. So we didn't really need a memory address to do this. We can just do at main apparently. So PDF, which is easy to remember, right? At main. So we should disassemble the function main into nice colors too. So this is really a screenshot moment, right? So this is easier than having a lot of stuff in Ghidra, right? So if we use this, it's also nicer size of text for streaming. And yeah. So push RDP move. So we save the old RDP, then RBP, and then we move the stack pointer into the RBP. So we have the new one there. And then sub RSP10, because we want to make a variable space here, right? And it's not 10, it's 10, OX10. D word. Yeah, right, it has it up here. It's 29 degrees. I'm usually not sweaty at that temperature. Here's the name of the string is kinda exactly the string. Almost. STR dots. RC, RB. Yeah, that is a nice comment. So, and also we can see the exact addresses and everything. So I'm thinking if this one is 10 hex and this one is 4 and this is 10, what? Shouldn't it be both like lengths? So, by the way, we didn't run this one in Hydra, it was our own programs. No, I said it wrong again. They're two similar names. I don't know, they're not really similar, you know. Ghidra and Hydra, but sometimes I feel like they're both like dragons kind of thing, right? Mythical creatures? Well, I meant Ghidra, of course, you know. So let's do the same with so let's do PDF at copy art. So main is here, but not copy art. Why? Yes, I was like, it might be running out. Yes, it might be, but it was like just 50 minutes left, so it was not really. So here is copy art. And it did the hopping thingy again. So, what if we put this address there instead? And test. So these names. So I should remember this command that I'm scrolling up to and rerun it instead, right? That one could also do. And that one. So these are called imped out. Not like random stuff. There's the copy arg again. Yeah, so AFL lists them. But not copy arg. Yeah, sim.copyarg. Okay, so this is definitely not the same place. But this is the address I put here. So something is not, you're not supposed to use an address like that, right? But we seem to be able to do that with like anything then almost. Well, we'll see. Oh, ref from main. So it actually says here 58B 58B. So here's what it calls. And here I should have read the what it's actually calling, so I should have used that here. This is interesting. I'm kind of thinking, yeah, to screenshot this to preserve the colors, right? So I think I started not today, so we don't have share X up. By the way, this is a funny way when I search for ShareX. It is installed, as you will see, but I will have to use all the letters to find it. So funny. When I started, like, not every day maybe, but not far from it, you know? So, here we have the code for it. Here we have the shellcode we're supposed to use. And here we have me testing with GDB on this one and trying to find information. Now we're doing, well, time for R2, right? And first I'm going to put some of the stuff that we got. Let's actually put the commands to start it. So I'm sorry for all the scrolling, it's just because I'm learning this, right? As I run it again. Yeah, here I did it with the A and D. And I restarted it again with quit. And then I started it with only D here. So this is the final time I run it. Then we did AAA. There. So this is the interesting bit. And then there's lots of help. Yeah, this one is kind of interesting, right? Well, let's copy this one into the notes. The IA. So I'm just pasting it, and as you know, the coloring will disappear, unfortunately, though this doesn't have any coloring except for this. So IS, let's get the IS one in there. It's just nice to have like examples, right? And it looks kind of ugly here. Part of it is because of this. So I'll add new lines here. AAIA. I just pasted it in a bad way. IS symbols, and here there are actually distance between them. And then we have the AFL, where we have the names. So in this list, copy art is the name. So here it says only copy art. We can't use that name, so we need this name, as we noticed when we're looking for information about it later. So the AFL again, and then the AFL grep main, which is kind of nice, right? So I'm just pasting that one in there too. And then we have the actual. I'm kind of thinking Oh my god. I started my second obsidian by mistake. You don't want to kill the poor computer here. Yeah, I did click you. Don't die, stream. Yeah, so I've been streaming for 2 hours. It feels like 4 hours. So, I can move it. Can I close it? Yeah, I want to close it. I did tell you that. So, we were going to screenshot this. This is why I started ShareX. And let's do here. So I'll paste it here. And when we make this bigger, it will increase to its full size. So if it's hard to read, it's just because we have it like tiny now.
Dev Sutar says, ma'am, your channel are 24/7 live?
No, it's not. I've been online for 2 hours. So right, so here we have. I'm going to screenshot this one too here. So welcome back. So let's make a screenshot here.
MadMax1551 says, hi, do you have a paid HGB account? Or free?
I pay for TryHackMe, but not Hack the Box, unfortunately. But I might do it. So I can't do boxes on stream from there. There, so now we have both main and copy art. Disassembled by R2. And here we're building R2 nodes. And I found this old document.
Thank you for answer.
Yeah, sure. So I might actually, but I'm thinking I should do more stuff on TryHackMe first, so I don't have to pay for 2 things at once, you know. Trying to be able to afford stuff. Yeah, so so PDF means print disassembly function. Doing so will give us the following view. Right, so we should actually have print disassembly function, right? What is AFL? Function list, I guess, but
I was meaning try to hawk K, but I for some reason write HDB.
What did you really mean to type? I don't know. Hack key. So let's see. We have more stuff in this file that we can use. Did it say anything more that I missed here about what AFL? What does AFL actually stand for? I guess it's analyze.
Rip Lottie says,
List.
Can you make me Roblox hacks?
No. That wouldn't be a good thing to do, right?
Dang it.
Note that memory addresses may be different on your computer. As seen here, there actually is a function, print assembly function, and then we have the core assembly language involves using registers to do the following: transfer data between memory and register and vice versa, perform arithmetic operations on registers and data, transfer control to other parts of the program. Since architecture is x86-64, The register is 64-bit, and Intel has a list of 16 registers. Right, so I do have a list. It's not here, right? It is somewhere else. So it might be this one. No.
I'm going to follow you.
Fixerbot says.
Welcome in.
New follower Riplotty. Less than 3.
So yeah, here's where I started. Why did I start to put them in NASA? Because that's kind of stupid, right? This is nothing to do with NASA. It's just another ASM. So let's actually merge the files together. So we'll just cut this and let's delete this file here and put it in here instead. We also have this file, but it's mostly links. So I will replace those images with something better too. So I did add the 32-bit versions here, and I intended to add 16-bit versions too, but they are kind of simple, right? It's just to cut away the letter in front. Maybe something else though. Yeah, and also these are with D. I didn't. Yeah, so I put that here. D to. Well, I guess let's add this R15D, right? Even though the registers are 64-bit, meaning they can hold up to 64 bits of data, other parts of the registers can also be referenced. In this case, registers can also be referenced as 32-bit values as shown. What isn't shown is that registers can be referenced as 16-bit and 8-bit, high 4-bit and low 4-bit. The first 6 registers are known as general purpose registers, while RSP, RBP are special purpose, and their meaning to be explained later on. To move data using register, the following instruction is used. Move queue source destination. I'm kind of thinking, should I add like instructions here? So I know some of them, but we haven't written anything down. And there's also the use upper or lowercase, right? Because this isn't pretty to use all uppercase. Don't think so. So let's do instructions, right? So so what does actually move Q do? Transferring constants which are prefixed using the dollar operator. Moving $3 REX would move the constant 3 to the register. And now we're in the opposite direction of what we've been doing it. So I didn't really look here. No, this is still in the right direction because it moves this to this. So let's look again here. Yeah, and move Q, of course, if this is a constant. So let's not dig too much into this, more than that we will have to add move Q here later, but let's do nothing about that now. Transferring values from the registry to move Q, RBX, RBX. Which involves moving value from RBX to RBX. Yeah, so they're different direction than we're using now. Transferring values from memory, which is shown by putting register inside brackets, e.g. move Q. Yeah. From memory, yeah, I remember this. Which means move value stored in. The last letter of the move instruction represents the size of the data. Quad word for Q. Meaning 8 bytes or 64 bits. So they're doing like a basic quick assembler here, but source destination. So what we're using is destination source. So this is like copying this would be a bit off. And also Q is not used, right? We're just move. So what if we look at our stuff we had yesterday? So many things popping up. You can have more than one program open at the same time. Click the tab to switch between them. Okay. Yeah, we already have this open here, so let's see. So as you can see, we also have the same here. This is a function add. We compiled this in C. We opened our hello2 here, a basic test program to test. Looking at the assembler here, Ghidra. So what I tried after this was to make an assembler file from this, and that didn't work. So, but then we also did. Let's see. Let's open this again and make a new tab, and let's CDP. There and CD. I think I put it in C. Oh, my A got hopped. So here we have an ASM file that's actually created by GCC by compiling the hello2. So if we just arrow up here, we should get the command kind of soon. Here. This is how it started to exist. Right, I mistyped. Let's first just do this. And let's do... because I fixed it in my notes, but I didn't fix it here. So we want to see this as assembler. And we want to also do the same to hello2. And now let's look at this directory again. We have, I forgot the S's. So this one needs an S. And this one needs an S. Yeah, I could see they got too big. So now this is an ASM file and this is another one. So if we know, if we cat hello dot ASM, this is what GCC created from our simple. Actually, let's cat the C file too. So this is the C program. So it's just print hello, nothing else, and it creates this. So it uses printf here, right? So this is what I was trying to realize. We can also see here we have move Q, and here we have this directionality too, RSP, RBP. So we know that this is going into this. Suppose that's what's supposed to happen here, right? These I don't really know. CFI def, CFI offset 16. 616. So I'm assuming these are like messages to the next step, to the assembler, but section string hello dot text starts here, dot text here too, dot section global main type main function. Yeah, I'll like have to check into. Let's do it right now. So I think the lasagna is done. We'll see if he needs help. My kid. So I'm going to copy this. Oh, gosh, it's so annoying. No, I'm moving the mouse. Copy. And this is on the level where I think ChatGPT can help. It kind of like messed up yesterday. So please explain every line. Also the dot CFI lines. Also the ordering source destination. We used NASM yesterday. NASM uses destination source, right? So I know that this is like common, that different ones uses different. It's just, couldn't someone just say, well, do like everybody else and do this way, right? Why not one way? Well, let's break down the assembly code. Yeah, and it realized though we didn't have a return 0. Let's break down the assembly code generated by DCC when compile a simple hello world program. Original C, yeah. The assembly code you provided is output after running the C compiler.s flag, which produces assembly code. Let's go through the code line by line. File hello C indicates the name of the source it was compiled from. Text dot text. This directory tells the assembler that the following instruction should be placed in the text section of the binary, which is where the executable code lives. Section row data. This directory switches to the row data, read-only data section. Section contains constant data such as string literals. So since hello is a constant string and not an input or anything, and not a buffer or whatever, it's there. So this is the label representing the location in memory where the string hello is stored. Okay. So LC0 dot string hello. Switches back to text. Global main declares main as a global symbol, meaning it can be accessed from other files important to the linker. And to switch back to the notes there, we can see in the images here, right? So this one has at main and this one has at sim dot copyarch. So that's why then that is. So type main function. Specify that main is a function. This helps the assembler understand how to treat the label main. Okay. So did we have we didn't have any other functions. I should have done the other one. LTB0. This is a label often used internally by assembler debugger to mark the beginning of a function block. So it is here beneath the main. So dot CFI start proc is the first line there of the main. This marks the beginning of the common frame information for the function. CFI is used by debuggers to understand the stack frame layout. Okay. And then we have the push RP. Pushes the current base pointer onto the stack to save it. This is the first step in setting up a new stack frame. Tells the debugger that the canonical frame address CFA is now at the stack pointer plus 16 bytes. The CFA is a reference point used to calculate the location of other elements on the stack. This indicates that the old value of RBP, which is register 6 in dwarf debugging, okay, is stored in a 16-byte offset from the CFA, which is the location when RBP was pushed. Move Q moves the current stack pointer RSP into the base pointer RBP, establishing a new stack frame. So thus we understand these are new. So CFI def CFA register 6 tells the debugger that RBP is now register holding the CFR rather than RSP def CFA register. I'm like in between thinking this is not what we should focus on and wanting to know everything. So function body, VA, and now with the quad again, quad word. Dot LC0. Yeah, this is there. Percent RIP, RAX. This loads the address of the string hello into the register RAX. Yeah, and I have to remember it's this direction here. And the RIP addressing mode is relative to the instruction pointer, which makes the code position independent. So I think I might not read more because my throat hurts.
Let's break down the assembly code generated by GCC when compiling a simple hello world program. The original C code likely looks something like this. Move %rax, %rd, moves the address of the string, now in %rax, into %rd, which is the first argument register for function calls in the x86-64 calling convention. Movelow $0, %ex, sets %ex to 0, which is typically used to indicate that the number of vector registers used for floating point operations is 0. This is a requirement before calling certain functions like printf.
So we read this yesterday too.
Call printf at plt, calls the printf function. The at plt suffix refers to the procedure linkage table, a mechanism used for dynamic linking of functions.
I just thought of what to ask it next.
Movelow $0, %ex, sets the return value of the function to 0, which is the convention for a successful exit. Pop %rbp, restores the old base pointer by popping it off the stack, effectively dismantling the stack frame. .cfi_def_cfa7, 8, updates the CFA to point to the current stack pointer, %rsp, register 7, plus 8 bytes, which is the stack state after the pop %rbp instruction.
Oh, we don't have to read this much end of the CFI for this function. And then there's another one.
.lfe0, marks the end of the function block.
I mean, it's not a function.
This label is used internally by the assembler/debugger. .size main, specifies the size of the main function by calculating the distance from the start label, main, to the current location.
So, we did this in a different way, I think. Was it like $1 or something here on the other one? I bet the string identifies the GCC version.
This tells the linker that this file does not require an executable stack. It's a security feature to prevent certain types of exploits. Summary of operand order. AT&T assembly syntax. The assembly code you see here uses the AT&T syntax, which is common in GNU tools like GCC. In this syntax, the order of operands is source, destination. For example, in move %rsp, %rbp, %rsp is the source and %rbp is the destination. NASM assembly syntax. In NASM, the syntax is destination, source. The equivalent of the above would be MOV RBP, RSP. Understanding this assembly output helps to see how high-level C code is translated into lower-level machine instructions, allowing the CPU to execute your program. The .cfi directives are crucial for debugging, helping tools like GDB navigate the program stack during execution.
Particularly those that are more closely aligned with Intel syntax. Yeah, I guess that's the thing, right? AT&T versus Intel. I just got a bit annoyed at call it just nasm. Jag kommer! Är det klart? I'll have to go to my kids. Let's just ask it first. Please format this in nasm format. So, and then we will run it. So wouldn't it be nice if they just could get along? Yeah, so I'm kind of thinking that it's Intel made the processor. So why not always use this, right? So, first of all, let's actually TTS this bit, because why not, right?
Yes, Hydra, like NASM, uses the destination, source operand order in its assembly representation. This is a common convention in many assembly languages and disassemblers, particularly those that are more closely aligned with Intel syntax. Operand order differences. AT&T syntax, used by GCC and the GAS assembler. Operand order is source, destination. Example, move %RSP, %RBP means move the value in %RSP to %RBP. Intel syntax, used by NASM, Hydra, and many other tools. Operand order is destination, source. Example, MOV RBP, RSP means move the value in RSP to RBP. Key points to remember. GCC/at and T syntax, registers are prefixed with %, and the operand order is source followed by destination. Intel/NASM/GDR syntax, registers are not prefixed with %, in most cases, and the operand order is destination followed by source. Example conversion. In AT&T syntax, move %racks, %RBX. This means move the value in racks to RBX. In Intel/NASM/GDR syntax, MOV RBX, racks. This means the same thing but follows the destination, source order. Usage contexts. AT&T syntax is typically found in Unix-like environments, especially when using GNU tools like GCC. Intel syntax is more common in disassembly tools, Windows environments, and documentation. It is often preferred for readability by those familiar with Intel architecture. When switching between these environments or tools, keeping track of these differences is crucial to avoid confusion, especially when interpreting assembly code.
Yeah, so I guess it's a bit of a mess, you know, when you're So it's converted it to what we would use with NASM. So global main, extern, printf. This is what we were testing last time, and what we needed to know. And I added this to the file. Well, let's actually compile this, or rather assemble it. Let's TTS this while I do stuff on the other computer screen. So, yeah.
Chat history. Recent. GCC assembly code explanation. ELF file components explained. Assembler code explanation. Shell code breakdown analysis. Listing app memory contents. Upgrade
Well,
plan
let's
get
just do
GPT 4,
test,
Dolly,
right?
and more. Chat GPT. Please explain every line, also the .cfi lines. Also the ordering source destination. As NASM uses destination source. Kali / programming / C. $GCC hello.co hello.asms. Kali / programming
So that
/
was
C.
not my intention.
$cat hello.asm.
I just wanted the last bit.
File
Right?
hello.c. Changes made. Section names.
So
The section
annoying.
names .rodata and .text have been updated to .data and .text to match NASM conventions. Labels. Labels like .lc0 have been changed to lc0. NASM allows simpler labels without the leading dot. Instruction syntax. Operand order has been reversed to destination, source. Register prefixes, %, have been removed to match NASM syntax. Directives. .global becomes global in NASM. .extern becomes extern in NASM. .type is not necessary in NASM. Explanation. Section .data defines a section for read-only data, example strings. LC0 db hello, 0, declares the string hello, with a null terminator in the .data section. Global main declares main as a global symbol. Extern printf declares the printf function as an external symbol. Racks, rel lc0, loads the address of lc0 into racks. Rel makes the address relative to rib, which is necessary for position-independent code. X or ex clears ex, equivalent to mov ex, 0, but more efficient. Call printf calls the printf function. Ret returns from the main function. This NASM formatted code should work with the NASM assembler, provided that printf is linked correctly, typically requiring the inclusion of the C standard library during the linking phase.
I meant the naming convention, not the name itself. Let's just change it. So that's what this really is. It's just a label for a section in memory where hello is stored, as it says here. This is not how we did it before. So it changed it added a comment here. Oh, that's annoying. I didn't really. Let's just read this. I didn't listen to it if I did digest it. Well, so before we change anything, you know, let's test it first, right? So so yeah, so this F thing here might not be. Let's test it. So that's interesting. Funny that I've done so similar commands, you know. What did I really do now? Oh right, F doesn't. Oh right. This is to be linked later, right? Let's just test it like this. "16-bit mode." Okay. So we need to GCC this thing too. I forgot it. So well, this is doing it the other way around, you know. So this is not it. So I should have called that like something else. Like O or something, right? Is that better? So let's ask it. I don't remember the GCC one, but I could figure it out. But I feel sick. I guess I'll say police again. So commands meaning, yeah, this is exactly what I did. I called it .o even. Here, yeah, this does LD, but I heard that when it's 64-bit, you could do it with GCC. But we can't, right? Because yeah, let's do the LD one. Let's do the LD one. So LDO test. Sorry, I must select it first. LDO. I don't think I ever used LD, at least not in a long time. So test test.o lc dynamic linker. Oh well, I guess I will type it. 64 LD Linux x64 .so .2. Right. It wants us to use start instead of main. So we used main because we were going to do it with UCC. So what about the entry symbol? Yeah, it expects underscore start, so it changed it. Yeah, with main. And then we would use E for entry point. Okay, so I'm assuming this is just a warning, so it would have done it anyway, but let's do it like correctly, right? So let's add an E here too. E main, right? No errors. And this is why test was not executable before. Let's do that. Still not? So this went colored, so I was curious there. So trying to get this. Yeah. So we can see it there, right? So, what on earth? Yeah, so it filled out the full path there too. So let's try something else. CP test 2, test 2. So now we have 2 tests. They're there, you know. Yeah, test 2 doesn't exist. And it's here. We can even see what it looks like. our nice elf file here. So also the same. We could also I'm trying to remember stuff instead of taking notes. I remember the PDF thing, but not the one before. AFL. AFL. A PDF. It mean. Right, we have a box running too. Add another hour. Not that we are currently using it, it just was to test the file. Well, we can actually read more here first too. Start usually used for start point and assembly, and C calling convention main. So, what about using GCC? I'm assuming it will just give us the command. Yeah. Here's how you can integrate some assembly code into a project using DCC. Yeah, so this is not exactly what I meant. My asm function. Extern. Void. That's good too. It was a long time since he used assembly in C code. And that was for PIC processors, I think. Yeah, so this is the same command, and then yeah, because they're using the C one too. So what if we were to just skip that and let's do just do GCC. Actually, let's my god, arrow up, LD, right? So GCC. Let's see what happens from this. What? Test O is not missing. Oh, it's missing no stack section implies executable stack. This behavior is deprecated and will be removed. Warning, relocation against. And read only selection text. Recompilable FPA. Yeah, I remember that one. Final link failed, bad value. Yeah, let's give this to. So now it will see what I was trying to ask it to do. So I'm sorry for not reading as I usually do aloud, cause I'm got a cold and sore throat. No P. Okay, so we had to set it manually because it's not in the file kind of thing, right? Main, just like the other command, but they're related. Yeah, so I'm kind of thinking we're done with this testing. There's so much else I want to learn, you know. Let's just yeah, put it in TFP. I'm just curious about this. So let's just remove the test2. It was just a copy. Did you notice the same thing I did? The file test is now gone because it's probably because we run that failed command, right? So if we do the LD one again, without having a file there now, we now have the test. If you /test, we still get the same problem. And we can also /tab, /tab. Yeah, so this is there so much. Seriously, right? So I'm curious now. Oh. Okay, so it says the path might be wrong. So it sounds odd. So I'm kind of thinking, well, let's find this, right? And this time we're looking for it's just going through it all. Yeah, so we're still in ASP, so we're in the correct directory, but this path was wrong. So USR, I was kind of expecting an error here if it wouldn't work, but so lib x86 underscore 64 Linux. No. There. So what about this now? So did I miss it again? USR lib I think I used the right one, didn't I? So I've never seen this error message before. So is this not the same as mine? Oh, there's an x86 at the name too, so I did make an error. But we got a segmentation fault now. So what I'm doing is I'm just pasting the output into the ChatGPT that gave us the code from the start, or converted it rather. So segmentation typically indicate your program tried to access a valid memory location. This can happen due to various issues in your assembly code. Well, it's assembly code. To debug this, you should check the following aspects. Make sure your assembly code is structured. So is this the same as it gave us when it translated it from, I guess, AT&T style? So let's compare this to the Nano. Test. What ass? So it has changed stuff, but not enough. It added a comment there. This is the same. It added a comment here and split these two lines up. And then it split LEA, REX, also no. And then it has the XR. Did it just skip this line? Let's see. Yeah, it did, because it did RDI at once there. So, fine. It's not really like it's... You know, these kind of things feel very... Why, you know? But it did the same thing as the other compiled by GCC one. C code compiled. So RDI EAX and then we have the cold printf, and then there's a movie AX0 here, which is the same thing, and then this is the same. So it's like oh, let's change these tiny things around a bit and see if my code works better. Not mine, but it's, right? Yeah, so we really wanted it to be the same one to test. Whatever. Oh, then we know NASM again. NASM FL64, and yeah, so mine is a different order than its, but that's okay. And then we have the LD, and let's see, O test, test O, E main. I'll see dynamic linker and the correct path with x86 in its name. And so we get a segmentation fault still, though I didn't make all the changes it had. So let's change this to move to, though why on earth it would change anything, I don't know. So should be the same. So let's actually change this one, it annoys me. Message, and it might read that as something else, you know, too. Yeah. No. Test2.s. Was a segmentation fault what we got yesterday. Now we have its code. We just do
Bam
the same,
says,
but change to test
"Afternoon,
2.
fix it. I hope you're well."
Hello. Yeah, I'm okay. I've got a bit of a cold. Otherwise, I'm great. You? I hope you're great. So I am trying to test and learn this, and oh, test 2. So now let's use our own ones instead. In here we have hello.asm, right? And if we do hello, oh, why? Okay, sudo chmod well, so now we should have permissions to run
The number
it,
of
right?
times I've typed sudo chmod 755.
Yeah. So now I don't care. This is just my Kali machine. So this one works, right? The test ones don't. But this one doesn't use printf, I think. So let's nano my hello dot asp, and here we're using syscall to write, not that. That's why it works, right? So I want to learn how to use printf. That's the purpose of this. How to call an external function. And maybe I'm just linking the whole wrong thing there. So where is printf? Oh, low battery. So to be able to understand the stuff, and like we're really doing buffer overflow now, we need to know all the things, right? We can't just not know them. So what is hello to really? So hello to. Yeah, I think this is a test. This is, yeah. So this is code from Ghidra. But now I know more things, right? So where's the cursor? So I think I already have done this. Yeah, we edited the wrong file. I think that might be the problem.
When I have the nano editor open and want to check another file, I just open it into another memory buffer.
Okay. Yeah, I usually have several tabs. I don't do anything advanced. I use Control S, Control X in Nano. That's what I use. And arrows in typing. So
Insert button, Alt F, Alt T, Enter.
yeah. So I'm sorry, but that's the reason I'm not using like Vim or anything else. Or I just want the simple stuff. You're welcome to teach me stuff, but I don't. I'm not like coding in Nano, right? I'm just using it for testing stuff. And what we did last time, I think we actually opened it in Mousepad instead. And we also have code. So if you want to do something more advanced, we'll just open it somewhere else. But now I just wanted to add the under the
Not
text
teaching.
section.
I just like having multiple documents open and switching between them.
Okay. So let's just do. Yeah, also this one has global start, right? So let's do extern print affair, and that was a hello 2 that we have not yet managed to get NASM to do anything well. Right, so we don't need. Right, we need this. So hello 2. Also, should be a working one. So this is not correct probably anyway. But let's see if it says anything about this now. It didn't. So what if we now put this one to, come on, there. So I'm not sure about this path in this file, if this is the correct one. That's the problem, and I guess I should pick this apart. So now we're not using main, right? If I remember correctly. And it's called hello. We better call it hello here too, or it'll be very confusing. So I'm very interested in why these have these permissions, if that's what Mousepad does when it makes a file by default. So we have a hello too. When I run this, I expect the segmentation fault because we're trying to get the printf the same way now, right? So this must be something wrong with this. Extremely wrong. So I did. Well, let's open a new ChatGPT here and let's ask it how. So first, let's tell it it's Linux, it's 64-bit, and we want to all what I've done before has been based on my C example, right? So let's just tell it to simple hello world using printf and ASM. So no, and .asm file. Not to do it from C. My God. I didn't say to use C, right? So it made an empty .bss section. So calling the string hello. So do you see what I see? It's using syscall. I told you to use printf. So it's having problems combining the printf from C. Now we have an external printf here. And a hello world string, null terminated. And it's a start one. And I'm assuming it gives us, yeah, it's doing the no. Right. So we didn't do this before. We had this as an alternative. So also give me the ld command. This might not be the best way then. So where is the library on modern Kali? So let's see if we can do all of the things here and find the file for us too, because the path didn't work. Yeah, I'm thinking it's off. Let's look. So let's. Alright, I didn't want to open a new browser tab. I'm just hopping back to the right one. So I wanted to open a new tab here. So let's cd and so it's saying right, so lib64 is actually USR lib64, so let's go for lib64 here and look here. Right, yeah, so we could use this one, this path. Let's see if it is the correct one. Let's see what it really wants from the start is, yeah, I think it should work. LD Linux. I'm curious if it remembers what we just did, though it's a new one. So I'm curious. Well, let's just try both ways, right? So hopping back here, and first let's do its suggested GCC way, right? So I'm going to copy the code, and we're going to make a test3. So let's nano test3 .s. And let's paste the code. It's not much. It's the extern printf. Simple. Most simple one. Right? And then we're going to do well, I didn't actually click anything. I scrolled over there, and I think it loses the focus just from that. So test3. I have a command that does it all at the same time, I think. No, maybe not. So now we have a test3o file. Sorry. So GCC. Yeah. So this is the same, but with a 3. And what I didn't want to add before, so let's add it now. So apparently it still uses LD, right? Oh, So main. No. Multiple function start. Multiple definition of start. First define there. Warning, missing, no stack function implements execute stack, reverse duplicated. Yeah, we got this before too. So let's look at that code again. What did it really do? So global start and uses start here. Main is nowhere. Alright. I added main, but I should have added start, right? So I'm just... But it still says undefined reference to main. Okay, let's edit this and let's call it main, right? So that's an easy thing if it helps. So, right, we need to... Didn't I redo the NASM bit? Then I'm kinda... Oh well. This works. We did change the name of it. And... Warning. Missing note no stack doesn't imply execute stack. This behavior is deprecated. So segmentation fault. Yeah. So maybe using printf is not a smart thing, but you want to be able to call stuff, right? So calling external functions NASM. C functions, yeah. So extern printf strdb low. One opportunity. Yeah, write a C program. Are you on Windows or Mac OS? Then we need to know the rest of the answers. Yeah, so to our question or Google, let's add Alex here, right? We still get the same. Yeah. So I'm kind of digging into something I shouldn't really do, I guess, but it's a relaxed day today. Okay, so it's calling his own foo there.
Ivan Lim 7182 says,
Hi Fixit, it's been a while. I finally fixed my Twitch name Smile Smile.
Oh, nice to have your name back. Welcome back. Yeah, so I have a bit of a cold today, so I'm drinking tea and taking it slower. So, but I'm curious how to call. When I try to call printf from Soundreg segmentation fault, trying several ways. If I just use a syscall, it works fine to write to the screen, but I want to be able to call things. We could, of course, try our own. We can even make a C O file too. And just not use the this one. Right, and are these correct, these options? And did I try the GCC version? Yes. So I'm kind of thinking I should stop looking into this exact thing right now, because I'm really not trying to do this. I'm just curious why it doesn't work. So what did I really search for? Yes, Caban. So my kid's calling. So I'll just go get some spaghetti for him and misos. I'll just take the opportunity to get some more tea for me too. Let's just see if we can have something to TTS. This was resolved there. Shows separately how to call C from NASM and vice versa. let's actually start something else. This. So this one we going to TTS while I go and get the food.
Corland Cybersecurity Research. Knowledge is not an object, it's a flow. Please consider donating. HTTP URL. Exploit Writing Tutorial Part 1, Stack-Based Overflows. Last Friday, July 17, 2009, somebody, Nick, named crazy_hacker has reported a vulnerability in EasyRM to MP3 conversion utility, on XPSP2N, via packets.ormsecurity.org. See HTTP URL. The vulnerability report included a proof of concept exploit, which, by the way, failed to work on my MS Virtual PC based XPSP3N. Another exploit was released just a little bit later. Nice work. You can copy the POC exploit code, run it, see that it doesn't work, or if you are lucky, conclude that it works, or, you can try to understand the process of building the exploit so you can correct broken exploits, or just build your own exploits from scratch. By the way, unless you can disassemble, read, and comprehend shell code real fast, I would never advise you to just take an exploit, especially if it's a precompiled executable, and run it. What if it's just built to open a backdoor on your own computer? The question is, how do exploit writers build their exploits? What does the process of going from detecting a possible issue to building an actual working exploit look like? How can you use vulnerability information to build your own exploit? Ever since I've started this blog, writing a basic tutorial about writing buffer overflows has been on my to-do list, but I never really took the time to do so, or simply forgot about it. When I saw the vulnerability report today, and had a look at the exploit, I figured this vulnerability report could act as a perfect example to explain the basics about writing exploits. It's clean, simple, and allows me to demonstrate some of the techniques that are used to write working and stable stack-based buffer overflows. So perhaps this is a good time. Despite the fact that the aforementioned vulnerability report already includes an exploit, working or not, I'll still use the vulnerability in EasyRM to MP3 conversion utility as an example, and we'll go through the steps of building a working exploit, without copying anything from the original exploit. We'll just build it from scratch, and make it work on XPSP3 this time, smiley face. Before we continue, let me get one thing straight. This document is purely intended for educational purposes. I do not want anyone to use this information, or any information on this blog, to actually hack into computers or do other illegal things. So I cannot be held responsible for the acts of other people who took parts of this document and used it for illegal purposes. If you don't agree, then you are not allowed to continue to access this website, so leave this website immediately. Anyways, that having said, the kind of information that you get from vulnerability reports usually contains information on the basics of the vulnerability. In this case, the vulnerability report states EasyRM to MP3 converter version 2.7.3.700 universal buffer overflow exploit that creates a malicious .m3u file. In other words, you can create a malicious .m3u file, feed it into the utility and trigger the exploit. These reports may not be very specific every time, but in most cases you can get an idea of how you can simulate a crash or make the application behave weird. If not, then the security researcher probably wanted to disclose his/her findings first to the vendor, give them the opportunity to fix things, or just wants to keep the intel for him/herself. Verify the bug. First of all, let's verify that the application does indeed crash when opening a malformatted M3U file. Or find yourself an application that crashes when you feed specifically crafted data to it. Get yourself a copy of the vulnerable version of EasyRM to MP3 and install it on a computer running Windows XP. The vulnerability report states that the exploit works on XPSP2, English, but I'll use XPSP3, English. You can find a copy of the vulnerable application on ExploitDB. Quick side note, you can find older versions of applications at oldapps.com and oldversion.com, or by looking at exploits on exploit-db.com, which often have a local copy of the vulnerable application as well. We'll use the following simple Perl script to create a .m3u file that may help us to discover more information about the vulnerability. My $file equals crash.m3u. My $junk equals \x41x1000. Open, $file, $file. Print $file $junk. Close, $file. Print m3u file created successfully \n. Run the Perl script to create the m3u file. The fill will be filled with 1000 A's, \x41 is the hexadecimal representation of A, and open this m3u file with EasyRM to MP3. The application throws an error, but it looks like the error is handled correctly and the application does not crash. Modify the script to write a file with 2000 days and try again. Same behavior. Exception is handled correctly, so we still could not overwrite anything useful. Now change the script to write 3000 days, create the M3U file and open it in the utility. Boom, application dies. Okay, so the application crashes if we feed it a file that contains between 2000 and 3000 days. But what can we do with this? Verify the bug, and see if it could be interesting. Obviously, not every application crash can lead to an exploitation. In many cases, an application crash will not lead to exploitation. But sometimes it does. With exploitation, I mean that you want the application to do something it was not intended to do, such as running your own code. The easiest way to make an application do something different is by controlling its application flow, and redirect it to somewhere else. This can be done by controlling the instruction pointer, or program counter, which is a CPU register that contains a pointer to where the next instruction that needs to be executed is located. Suppose an application calls a function with a parameter. Before going to the function, it saves the current location in the instruction pointer, so it knows where to return when the function completes. If you can modify the value in this pointer, and point it to a location in memory that contains your own piece of code, then you can change the application flow and make it execute something different, other than returning back to the original place. The code that you want to be executed after controlling the flow is often referred to as shellcode. So if we make the application run our shellcode, we can call it a working exploit. In most cases, this pointer is referenced by the term EIP. This register size is 4 bytes. So if you can modify those 4 bytes, you own the application, and the computer the application runs on. Before we proceed, some theory. Just a few terms that you will need. Every Windows application uses parts of memory. The process memory contains 3 major components. 1 code segment, instructions that the processor executes. The EIP keeps track of the next instruction. 2 data segment, variables, dynamic buffers. 3 stack segment, used to pass data/arguments to functions, and is used as space for variables. The stack starts, equals the bottom of the stack, from the very end of the virtual memory of a page and grows down, to a lower address. A push adds something to the top of the stack, pop will remove one item, 4 bytes, from the stack and puts it in a register. If you want to access the stack memory directly, you can use ESP, stack pointer, which points at the top, so the lowest memory address, of the stack. One after a push, ESP will point to a lower memory address is decremented with the size of the data that is pushed onto the stack, which is 4 bytes in case of addresses/pointers. Decrements usually happen before the item is placed on the stack, depending on the implementation. If ESP already points at the next free location in the stack, the decrement happens after placing data on the stack. 2 after a pop, ESP points to a higher address is incremented, by 4 bytes in case of addresses/pointers. Increments happen after an item is removed from the stack. When a function/subroutine is entered, a stack frame is created. This frame keeps the parameters of the parent procedure together and is used to pass arguments to the subrouting. The current location of the stack can be accessed via the stack pointer, ESP, the current base of the function is contained in the base pointer, EBP, or frame pointer. The CPU's general purpose registers, Intel, x86, are 1 EAX, accumulator, used for performing calculations, and used to store return values from function calls. Basic operations such as add, subtract, compare use this general purpose register. 2 EBX, base, does not have anything to do with base pointer. It has no general purpose and can be used to store data. 3 ECX, counter, used for iterations. ECX counts downward. 4 EDX, data, this is an extension of the EAX register. It allows for more complex calculations, multiply, divide, by allowing extra data to be stored to facilitate those calculations. 5 ESP, stack pointer. 6 EBP, base pointer. 7 ESI, source index, holds location of input data. 8 EDI, destination index, points to location of where result of data operation is stored. 9 EIP, instruction pointer. Process memory. When an application is steered in a Win32 environment, a process is created and virtual memory is assigned to. In a 32-bit process, the address ranges from 0x000 to 0xFFF, where 0x000 to 0x7FFF is assigned to user land, and 0x8000 to 0xFFF is assigned to kernel land. Windows uses the flat memory model, which means that the CPU can directly /sequentially/linearly address all of the available memory locations, without having to use a segmentation/paging scheme. Kernel land memory is only accessible by the OS. When a process is created, a PEB, process execution block, and TEB, thread environment block, are created. The PEB contains all user land parameters that are associated with the current process. 1 location of the main executable. 2 pointer to loader data, can be used to list all DLL/modules that are/ can be loaded into the process. 3 pointer to information about the heap. The TEB describes the state of a thread, and includes 1 location of the PEB in memory. 2 location of the stack for the thread it belongs to. 3 pointer to the first entry in the SEH chain, see tutorial 3 and 3b to learn more about what a SEH chain is. Each thread inside the process has 1 TEB. The Win32 process memory map looks like this. The text segment of a program image/DLL is read-only, as it only contains the application code. This prevents people from modifying the application code. This memory segment has a fixed size. The data segment is used to store global and static program variables. The data segment is used for initialized global variables, strings, and other constants. The data segment is writable and has a fixed size. The heap segment is used for the rest of the program variables. It can grow larger or smaller as desired. All of the memory in the heap is managed by allocator and deallocator algorithms. A memory region is reserved by these algos. The heap will grow towards a higher addresses. In a DLL, the code imports list of functions used by the DLL from another DLL or application, and exports functions it makes available to other DLL's applications, are part of the .text segment. The stack. The stack is a piece of the process memory, a data structure that works LIFO, last in first out. A stack gets allocated by the OS, for each thread, when the thread is created. When the thread ends, the stack is cleared as well. The size of the stack is defined when it gets created and doesn't change. Combined with LIFO and the fact that it does not require complex management structures/mechanisms to get managed, the stack is pretty fast, but limited in size. LIFO means that the most recent placed data, result of a push instruction, is the first one that will be removed from the stack again. By a pop instruction. When a stack is created, the stack pointer points to the top of the stack, equals the highest address on the stack. As information is pushed onto the stack, this stack pointer decrements, goes to a lower address. So in essence, the stack grows to a lower address. The stack contains local variables, function calls and other info that does not need to be stored for a larger amount of time. As more data is added to the stack, pushed onto the stack pointer is decremented and points at a lower address value. Every time a function is called, the function parameters are pushed onto the stack, as well as the saved values of registers, EBP, EIP. When a function returns, the saved value of EIP is retrieved from the stack and placed.
So that was just while I was getting his food. Yeah, but I'm thinking there might be, so far it's just like been repetition, right? But it sounded interesting at the start. This is just explaining everything. That's great. So these are all stuff that I found from searching buffer overflow with a misspell apparently yesterday, and starting to open stuff and going for the links, right? And I had not even opened all of them, so I'll just continue here. So there are several of these, right? So yeah, so we don't want the basics again. But if there are things that are interesting, we want those. Yeah, so they're using gets, not fgets. They say this one would be secure. So I do have some food. Oh my, this is the room that we started at, right? So is this connected? I don't really mind, but
Types of buffer overflow.
so
Let us now look at some types of buffer overflows. Stack-based buffer overflow, A stack-based buffer overflow denotes a security vulnerability where a cyber attacker overloads a buffer residing on the stack, exploiting it to change the return address and execute arbitrary code. Heap-based buffer overflow. A heap-based buffer overflow happens when an attacker overflows a buffer on the heap. Such an attack can lead to exploiting a vulnerability of memory management, which then causes arbitrary executable code to run. Format string vulnerability. The format string vulnerability is seen when an attacker can manipulate a program that uses functions like printf with format string arguments. This leads to the overwriting of adjacent memory locations with arbitrary data. Integer overflow. An occurrence known as integer overflow happens when a value that exceeds an integer's data type capacity, 8-bit to 64-bit, is assigned to it, causing buffer overflows and memory corruption. Off by one error. An off by one error is a programming mistake that arises when a program allocates a buffer with a size that is 1 byte smaller than the actual data that needs to be written. This leads to data overflowing into adjacent memory locations, allowing attackers to execute malicious code.
Oh, that's too big byte for me. Okay. So what we did with this one is to SSH into it, right? No? Alright, I remember. This is the one with the Windows one. Yeah, it was the other one that was buffer overflows or something. Maybe SSH too. Yeah. This one we already peed to a Windows machine. That was horrible. That's why I wanted to make my own. Yeah, we didn't get this sizes of text. We got tiny stuff. Tiny things. Much tinier. Yeah, if this is talking about immunity debugger, sure. We can listen to this. This is a learning room, so it's not like we need to. Nothing gets spoiled. It's just learning stuff.
After successfully login, right-click the Immunity Debugger icon on the desktop and choose Run as Administrator. Immunity Debugger is a popular debugger for Windows that can be used for analyzing buffer overflow vulnerabilities and exploits. When using Immunity Debugger to analyze buffer overflow vulnerabilities, one of the key features is the ability to set breakpoints and examine the state of memory at various points in the program execution. This can help identify where the overflow occurs in the code and what data is being overwritten. The main window of Immunity Debugger is divided into 4 panels. Disassembly panel. This panel shows the disassembled code of the program, which can help identify the location of the vulnerability and the path of execution leading up to it. Registers panel. This panel shows the state of the processor registers, which can help identify how the program uses memory and where a buffer overflow may occur. Memory dump panel. This panel shows a hex dump of the program's memory, which can help examine the overflow buffer's contents. Stack panel. This panel shows the contents of the program stack, including any buffer overflows that may have occurred. It can also help identify the return address that an attacker may be trying to overwrite. The OSC.exe executable binaries are vulnerable to simple stack-based buffer overflows, where a custom-written OSC binary has been created with 10 different buffer overflows. Each overflow has a distinct EIP offset and a predefined set of bad characters. To open the OSC.exe binary file in Immunity Debugger, you should click on the Open File icon or go to the File menu and choose Open. After that, access the Vulnerable Apps folder, the folder located on the desktop of the admin user, and then the OSC folder. Finally, select the OSC binary file and click the Open button. To start the binary, click on the red Start button.
So we did this the other day, but I wanted more background information before. This just says, run this, do this. It doesn't say why, you know? I want the more deep understanding than just running a script and doing what it says. That's not what I want to do. So even if I can think what it might, be the reason, I want to know all the things. So, yeah, so I think that's where I stopped this thing. Alright, we don't need to read the script.
Fuzzing can be used to generate a large number of inputs that exceed the length of the buffer and trigger an overflow. This can help identify the exact point in the program where the overflow occurs and the data that is being overwritten. On your Kali machine, create a file named fuzzer.py and insert the content given below into it. This code is used for the fuzzing into the binary.
So we're currently looking at buffer overflow on Linux, so this is not very helpful right now though. So I'm sorry. Yeah. So, I'll just...
After running the fuzzing script, the program
a
crashes
reading?
at 2000 bytes. We will now generate a cyclic pattern of random bytes that is 400 bytes longer than the string that crashed the server from the Metasploit framework to minimize the error. We have generated this to find the offset variable. An offset refers to the distance between the beginning of a buffer and the location of a specific data element within that buffer. It means a program attempts to write more data to a buffer than it can hold. If an attacker can control the data written beyond the buffer's end, they can overwrite data in adjacent memory, such as the program's return address or other important information. By manipulating the offset of the data they provide, an attacker can control
Plus
which
where
memory
I-
locations are overwritten and potentially gain unauthorized access or
Yes,
execute
Ben.
arbitrary code.
So, my kids again. So I would prefer to read it for you, but so the string that crashes server from the Metasploit framework. Did they use that before? Because I missed that in that case. Maybe they did it before we started. Didn't I start at the top? Nah, I gotta search. This is the first hit of Metasploit and it's just in 2 places. Yeah. So it's just using it to create a string just as we read in Tiberius GitHub node stuffy thingy madu badu. So we could just leave this one to time out. We can add an hour to. So I was thinking that might be a short article to just check while I ate, but let's continue here. So the reason I hopped from this, reading this one, was that it's destination source and all other things are source destination. Meaning Ghidra and NASM that we use, what we do with GCC and stuff, it's this order. So it's a bit of a mess, you know. So I'm guessing we'll have to put that in the notes, like into sections. A lurk. Yeah, I guess I should make a lurk to moms, right? So adding that to the list of stuff to do with stream, right? I don't think it'll be today. It'll just continue being.
Madam Fabulous says,
I like them, but NBD. Hope your studies are going well.
Thank you. I hope the same. So we were like thinking of adding stuff here. There's the mess. So should I do AT&T? Do source destination, right? Interlude. Destination. Source. The notes will be messy. Let's make that an equals. Plus equals messy, not Bessie. Right? Let's actually see. I think it can do italics like that. As long as we keep that in mind, we can put anything here, right? So I'm kind of thinking. And there's also the percent and everything. And there's the percent characters and all the other things, right, that differ. So, getting examples like this, right? But there are still useful things there, and this is from TryHackMe for 2019 Christmas stuff. I closed that one, maybe? Yeah, because that was number 1, this is number 2. So it's not open. Also these words, you know. Yeah, very simple table. Should we just like insert table? No, that won't work. So A, B, C, whatever, and so I'm just going to mess with this a bit in source mode. So there are just pipes in between. And there are these lines. And then just add pipes. Is there anything special here? Like I'm thinking this is quicker than just pasting stuff in there, right? And then we have the so that made it all hop. So we need to change the copied characters there. Why is this twice? That's odd. So let's see if we hop back to live preview. So let's hop back to source mode and let's see. Yeah, this line is actually in here twice. That's kind of funny. And I'm also curious about why this line. Let's just paste it here again. No, it's just the same. So it's just the first one that's necessary, and the rest will be automatic. Yes. So then we just delete this column. Oh, I meant row. So we have those, and we can delete. Let's just do that. Delete it like that. There. So, because that's kind of nice, right? Yeah. So that's what this queue is there. But when we do it with a when we're looking Gita, we never have those. All the cues here. I think someone's biking outside with a noisy bike. Yeah. So this is a file that we'll probably never see again. And here are all the percentages. I mean the characters. It's not percentages, just present characters. So I do prefer the other way. So I think we had the other one up. Let's see. So when we look at it here, we don't have any of those. And it's also the other direction. So let's just go to main. So this is just a simple test with a second function called add. So this is, I compiled this with GCC, and then we opened it in here in Gita to see what it looks like. And if we were to use this way of writing, it would all look differently, you know. But I guess every way is a good way, right? That works. I'm just thinking, should I like copy a bit of this? I'm sorry, my nose itches. So let's actually copy this bit here. And it's let's leave that there, and let's copy this bit here too, because this is both an old document and yeah, right. Yeah. So when we looked at this, here. So in theirs, I guess there's a setting or something that they didn't tell us about. Because for me, I don't have any move L and stuff, right? Like they have, or maybe it's just the age difference. So this is 5 years old. This is R2 still. And we will get in help from this when looking at this. I just opened this box to have an example. So, but we want to finish it too. It's a learning one. But we're supposed to put shellcode in a certain place. And I don't want to test. I want to know, you know, where to put it. How many bytes should we put in there? Because testing I could do. I don't want to. I want to know. Let's just look at this one. Main 3 variables. Yeah, and this is when I was like, alright, this is backwards. So very definitely visible here with a 4. Yeah, and here we can see this is the machine code, this is the address. Sorry if I'm trying to read this and compare. So this is Google Docs, meaning this one image here, you can't like save images from here, right? That's one of the problems of it. So if I want this image, I have to screenshot it. I can't zoom it like this. If we go to the top, we can download it. Nah, we don't wanna. Oh, here was an image that we couldn't really even see. So, as we're not really doing this thing that they're doing, we're just checking stuff. The line starting, right, I should TTS, right? And it won't do it down here, will it? Let's test.
Double word L4 quad word Q8 single precision S4 double precision L8. When dealing with memory manipulation using registers, there are other cases to be considered. Leak source, destination, the line starting with sim.main indicates we're looking at the main function. The next 3 lines are used to represent the variables stored in the function. The second column indicates that they are integers, int, the 3rd column specifies the name that R2 uses to reference them, and the 4th column shows the actual memory location. The first 3 instructions are used to allocate space on that stack, ensure that there's enough room for variables to be allocated, and more. We'll start looking at the program from the 4th instruction, move low $4. We want to analyze the program while it runs, and the best way to do this is using breakpoints. A breakpoint specifies where the program should stop executing. This is useful as it allows us to look at the state of the program at that particular point. So let's set a breakpoint using the command db address. In this case, it would be db0x00400b55 to ensure.
So, I don't know, maybe it's better I read. I might break my voice, but... Right. So, 400B55. It's this one. So they were setting, we don't have this program at all, so we can't do this. They're setting a breakpoint as this one, and they will use then a command. They do PDF and then they do DC. What? Let's look, cause this was odd. So here D is debug the example file or running process. We didn't do the question mark yet. Let's do that. And let's add the notes here. So db is breakpoint commands. Sorry. So let's actually do db question mark then, because it's kind of interesting, right? So here are all the breakpoint commands. List breakpoints. Add breakpoint to main. Add breakpoint to an address. So that's how we would do it. And then remove db minus. So this is just an example too, right? We could use something else in main here. Let's copy this. And let's get the most possibly useful ones. So I'm just adding stuff here now. So let's add the db is list breakpoints. And then we have db sim.main add breakpoint. Well, where is obvious, right? db address. We're going to have to test this. So for some reasons I started itching. I don't want to get more sick. So db minus. All right. Right, so now we can stop at places. And yesterday we were playing with GDB, and it had also next and forward, and I'm assuming that we'll find this here too. Disable enable, we don't need that, right? But a breakpoint no return function, add a breakpoint at an offset from model space. So what I lack in this is we need controls, right? We need controls, but we can't search there. That's why we're putting it here, so we will be able to, like, let's for now, let's say that we search for next here, and then we get something about it in the next page, right? But if we had something about how do we do this, then we would. So let's read the main list. There might be some other help system. I tried help, but I didn't get anything. Then I tried question mark, and then I got this. So that's how I'm getting the information. Debugger commands. Yeah, so we do have the file too, right? So let's hop back over here. Because it was just about to get started, right? So DC is continue execution. Yeah, so let's run it using DC. So let's add DC here. This is also a DC question mark, so I'm thinking we'll need to find that question mark, right? It might be a DC N for next or whatever. That's what I was looking for. So DC. Continue until. Yeah, so not a lot more here. Continue until syscall. Until call. There's different ones. I'm just confirmed here that it actually is this. Continue execution. And that's what they're doing with their program here. We'll execute the program until we hit a breakpoint. Once we hit the breakpoint and print out the main function. The rec, which is the current instruction, shows where execution were stopped. DC hit breakpoint at. Then they do the PDF. From the notes above, we know that move instruction is used to transfer values. The statement is transferring the value of 4 to local CH variable To view the contents of the local CH variable, we use the following instruction: px at memory address. So this is how we get the memory information. So I guess we'll just do like something like this. And list memory. That would be nice, right? In this case, the corresponding memory address for local CH will be RBPs from the first few lines. Alright, so we can use RBP. That we want in our nodes. It can't select less. So an example here. So px at so we can use that. Instruction prints the values of the memory in hex. This is nice. It is all both forms there. This shows a variable currently doesn't have anything stored in it. It's just 0, 0, 0, 0. So I guess it starts with it. I don't remember the address, so let's execute the instruction and go to the next one using the following command, which only goes to the next instruction. So ds oh my goodness. So now we need to check here. ds step. So I missed this one. We need to get help on this one. So ds question mark. Right here we have all of the things. So to have some kind of order in this massive amount of data, I'm putting them in alphabetical order. Well, the full list of it first. So what confuses me here is that all the db and then it's like dr in the end. And this is 4 db question mark, so that's interesting. Yeah, these are good. really, for the first time, I will paste here and delete what I don't want instead of the other way around. Yeah, we can't have so much. They're also interesting. Skip. I'm like thinking we don't have to have all of the things. One instruction, one source line. So we have a few. So all of these are breakpoints. Then we have control over the execution for those, and these are the memory. Yeah, I'm starting to get very tired. Well, it's not like I'm going to do anything else if I stop streaming, you know? I would just talk a bit less, right? I don't talk to myself. I'm trying to talk less now, though. Save my voice. This shows that the variable currently doesn't have anything stored in it. We read this. The first 2 bytes have value 4. This shows. Let's execute this instruction to go to the next one using the following command. DS. One instruction. If you view the memory location after running this command, get the following. So 04 there instead. And we can see that the first 2 bytes have the value of value 4. If we do the same process for the next instruction, we see that the variable local 8 has the value 5. So I'm just looking at this here, which is now here. It's overwritten in the 1890. Yeah. So I was like, where was I reading? If you go to the instruction, removal local 8 EX, we know from the notes that this moves the value from see the value of the EX register. We can use the command dr. So dr to see the contents of the registers, and I think that so we're not currently running it on this one. Well, we kinda are, right? So it's, when I quit it, it always says, do you want to stop? Right, let's actually put this one here with looking at the memory. So dr list registers contents, I guess. Execute the instruction and run the dr command again, and we get this. So this technically skips the previous instruction, but the same process can be applied with it. I couldn't TTS this right. Sorry for not reading aloud. We expect it to be 9 after executing, and we execute and it's 9. The next few instructions involve moving the values in registers. Right, so I have to remember it's this direction. After that, a string, which is the output, is loaded into register, and the printf function is called in the third line. Second line clears the value of EX, and EX is sometimes used to store results from functions. Clears EX here, so we can quickly see, you know, if it's this. The directionality, you can see it very quickly, right? I'm just looking at it. What is it's not putting EAX in 0, right? The general formula for working through something like this: set appropriate breakpoints, use DS to move through instructions, and check the values of register and memory. If you make a mistake, you can always reload the program using the OOD command. OOD. So, yeah, so it looks like it still does the same thing, which I would kind of assume, but still. Oh. So we don't have to restart it, R2, we can just reload it. That's nice. And that was the end of it. And this was very good. But I think we've extracted all the knowledge from this. There was another duck too.
The breakpoint is set. We run the PDF at main command.
That was not what I intended to do. I was actually going for the dark reader. Because it was kind of hard to read it, right? At least I want a quick look. Let's keep it dark, I think it's good. We can TTS this. I don't know about. Yeah, so. Anyway, if statements. I don't know why this says, but let's check it out, right? General format of if stem printers, if do stuff, else do stuff. Or else if, else do stuff. If statement use 3 important instructions in assembly. So I'm actually copying whatever. Let's copy both before and after, right? Yeah, it made it. I thought so. It'll get the table if it gets some stuff before and after. So CMPQ, and there we have again the Q for here, quad word. It's like computing a minus b without setting destination. My god. Test. Yeah, so I remember these. Instruction I use to transfer control to different instructions. And this one needs to be deleted. And this one got fat, bold. So let's just leave that there. unsigned integers, and so it cannot be. We can actually TTS it here.
The last two values of the table refer to unsigned integers. Unsigned integers cannot be negative, while signed integers represent both positive and negative values. Since the computer needs to differentiate between them, it uses different methods to interpret these values. For signed integers, it uses something called the 2's complement representation, and for unsigned integers it uses normal binary calculations.
So, we don't need this. And that's also says unsigned. So this is from this well, Advent of Cyber 2019, I guess. Remember to run. E as in syntax add. So there's more information here so that we didn't get, you know. So I was searching for different things. So the last one here was because I noticed I was searching, for example, for x86, since the ones mentioning this. So these I did kind of long ago. So I've been searching for different things, and this is when I got the, I don't know, cyber ones. So this is the actual room where these notes come from. So here is the first one. So I guess this is the second one. So we could download the task files if we want to. Well, this was the one we just finished, and the questions to that one. Let's just see what they look like. I guess we can open it. Challenge file. And oh, I didn't open the same thing. Alright, so we have if1.c here too. Yeah. Atmos Studio is the default. We could do that. I thought it would be Visual Studio as default.
T minus 4 minutes.
Oh, sorry, I was muted. It's a default thing when I start streaming now, the countdown. So I just was saying, what did it crash right now? Did it crash some time ago that I didn't notice? I don't know. So I think more things in my computer kind of crashed, right? So the stream still says on Twitch that it's 5 hours, meaning it was not a long dip. YouTube is just crashed itself on my computer. So let's see. I'm just putting a continuous here. Comment on the YouTube one. So well, always nice to have crashes, right? Making you wake up a bit. So, I don't know what this is. Remember to run. So, we'll need to Google this, because it didn't say there. Let's actually close this, cost memory, you know. Or I could have Googled there. We have too many things open, so several of these have malware stuff. So I was kind of thinking maybe I should do all of these ones paths that are like blue too. Right? So I have done these, implementation testing. That was like the first intro, pre-security. I have not done these. This one is easy. And then we have...
Stream about to start. 1 minute left.
We have cyber defense, SOC level 1. So I'm thinking I should have like all the sides of things, right? So I don't know a lot about MITRE, for example. Right, really not a lot. All that I learned is like from watching a few courses, like this ransomware summit. That looks kind of fun to make scripts to find stuff, right? But yeah, I'm not going blue, like. But you need to know all the things. So maybe I should, I haven't really, I think I did a few things actually in this because I was trying to keep the streak up. I know it's just lost at 0 always. It better not to care about it. Because it's just, I'm not gonna script something to keep it up. It's not worth it. So maybe do the suck level 1 and the security engineer maybe. Are those are the easy ones, and there are also the CompTIA and Test Plus. But I think we'll get most of this even more by just doing the ones I'm already doing, right? I'm gonna finish that one too. Let's see what it is. This won't have, right, making malware. So introduction. Yes, I was like, where's the rest? It didn't pop up. So I have to enroll in it to be able to see what I've already done, but I'm thinking I've done most of it. Like, very much most of it. Yeah, I think that this Active Directory will be in breaching. These Active Directory ones will be in the one I'm doing currently, which is the offensive pen testing path, right? So they overlap a lot. And the current one on the path is the buffer overflow prep, which is not like telling all the basics. It assumes knowledge, and that's why we're learning more. So that was my hobby getting home. Yeah, so I was kind of thinking, let's look at this one again too. I will do that one when I have more knowledge. Was there any good links there? I think we opened like everything. Yeah, and this one is also in Windows. Now let's close this for now. And this one was the SOC level 2. It also had a lot of malware analysis there. So I'm thinking, if you analyze malware a lot, then you will know more about this admittedly, right? So all of the malware bits. So it's both for like making malware and analyzing it. So we don't have to do all of it, of course. Buffer overflows for dummies from Sounds Institute. Okay, what's this? 2002. No reprocess. So this is like an ancient thing. Okay, we download something here.
My stream, when knowledge reigns supreme, calm and collected. I'm about to go live, you know what I mean. Got high X.
So this is what makes me think I should not stream to YouTube too, because it's so complicated to start it again. When I was just doing Twitch, it was so easy, crazy easy. Just click stream and you're up, you know. Now I have to manage stream, create a new stream, and on YouTube it doesn't connect back. On Twitch it connects back to the old one. Yeah. Let's just close a few things.
T-minus 4 minutes.
Yeah, we're getting another countdown. So let's start from one side and delete a few things. So this is not interesting anymore. I was googling for buffer overflow and I've found this one too. That was at first I thought when I clicked it I thought it was Tiberius one, and this is his one. So he just started explaining this here. We could look at this, but it's like an hour. And I started looking at this too. And this is where I searched. And this is where we started reading. That's good. Oh, this one too. I have not started looking at this one. I'll have to look at this one. So let's see if I can catch this tiny fly that annoys me. Did I get it? It's so tiny, I'm not sure I would see. Well, so I feel slow today too. And actually just doing this 2 times makes my hand hurt. I hope this is not like the flu, not just a cold. And why do it itch? Hopefully just I'm sweaty. So let's actually open the window a bit more, because it says it's 23 outside. It's been raining even. It's been raining. So what was this? Course materials for modern binary exploitation. Oh right, so this was like one of the links said more modern stuff, right? So actually let's add a folder. Let's just do BO for buffer
Stream about to
overflow.
start. 1 minute left.
Yeah, let's see if we can crash the stream before it's actually officially starting again, right? I think at least Twitch hopefully kept together and boo. Yeah, this one. That's more advanced things too, I think. What's this then? Oh. Non-commercial wargame site. Challenges. Fun. Toddlers. Yeah, so this was one of the suggested links. So smashing the stack for fun and profit. Oh, it's all text. That's nice. Yeah, so I don't want to have all the things up. That's why I could just start reading it too. And we also have this one that we have started reading. And that's linked. This is someone else having a video on this, on that room too. So we already have Tiberius is up here. So I think this one is good too, actually. Though my problem with them is they're talking so slowly that I like die. I speed it up, of course, but I don't want to do it on stream. So, beginner's guide. So, seems like another, and also with immunity debugger. So, of course, we get a lot of hits when we search Google for it. So, is this the same as the other one, right? Yeah, but this one is 5 years old and this one is 2 years old. So then I should probably watch this one instead, and this one is a lot of short bits. Yeah, I don't know. It's not like the basics have changed and this is basics. So why am I not at the start of this? We looked at this, right? We started TTSing this while I was like making food. Right. We just started down here because it was looking kind of basic information there. Yeah, so I realized it's the same room. So yeah, I'm kind of thinking we can just close this one. Yeah. Oh gosh. And this is why I really wanted to close, because so what is this? Not 6 students. 6 years old. This is we got that link from somewhere else. I also document that we started reading with the TTS, not the other one that we just hopped to a bit in. zeroday.io, kinda cool URL, right? I'm kind of full now, right? We don't need any. If there's nothing like, oh, this is a wonderful thing. This tutorial. I think that might be the same. We'll see. Oh, that's just Python courses. Do stack buffer overflow good. Yeah. So I'll just put some more links here, and then we will see if we might do something else for a bit. Exploit development practice. Is this the same? So that was a long list. This thing keeps clicking. Let's see if I can make it stop. So, another one. There I am. So, on YouTube it reset the title too. I can't go in and change it for the third time, right? This is a 5-year-old one. So the reason I had not the purple is because I used the list, I guess. Okay. Oh, you did my room. I want to watch you see what you thought. What did you think of his process? Yeah, so we can look at that one. Let's put it in here. So it's not that it would be hard to find again, but someone thought it was worth, you know, putting it at the top there. Buffer overflow for the OCP exam. This is a short one, really. So a lot of people say OCP. I'm like, don't you just want to learn the things? Do you have to learn them for the tests? I mean, I just want to learn.
In this video, I'm going to do a walkthrough of the buffer
it's a
overflow
room
methodology
again.
for the OS.
So why? Maybe they have insight, you know, into something, but it's kind of short compared to the others. Why would someone list several of the same thing? Only is all you need, and there's another one. It's the same video. Was the video good enough to complete? I mean, it was 13 minutes. I assume you would need more than 13 minutes to really understand something, right? If it's not amazing. So, text and tools. So it kind of says the same, but I think this one looked better, like structured and not just based on that room. Buff, fuzzer, pie. So, I'm a bit like just putting a GitHub page with no information, just a script. So I'm opening one at a time now because of the crashes, you know. We don't want to open too much at a time. So this one looked short, not a million things. I might actually read this now. Not like what I really hate is when you read like people saying like, oh, I thought this was a cool thing, so I thought I would explain it in this way and that, and this is the reason why I'm doing it, and you know, give me the facts. Right? That's what I think when I make like YouTube videos too. Okay. So let's open that last one. No, there are more. Cheat sheet. I could close my door. Yeah, I think my throat is actually better, but I'm not talking intensely, I'm not reading. But that's good. Oh, another room, we don't want those. The aim is not to do it quickly, but to do it in a way that we'll learn as much as possible. Oh. Oh, let's put this one in here, but I think it's other stuff too. I'm putting it there so I can have it separate. Yeah, I think I've seen this list before. I made a presentation about buffer overflows on my YouTube channel. Hope it helps. And it's the same room again. So I don't want a walkthrough of the room. I want to know the background of everything so that I can learn it good. I've thrown away several of these. Whatever. Let's put it in there then. Since it was someone's own thing. It's 2 years old too. So that's that page. Manual memory management. HackingCPP.com. This was not really what we wanted, right? It's kind of nice to see the sea and what's actually done. The Dark Ages. Dude, the Dark Ages was C, not C++. Yeah, so this was not what I was looking for. This is a forensic thing, which might teach you stuff, right? And I also thought that was fun that it is on malicious PDF files. it might not be a bad thing to know how to check your PDF files, right? Then we had one of the searches. Here are these are different years. So here's the last of the file. I just was going to Google this and stuff started crashing, right? I don't dare to open more tabs without closing them first. Well, I guess we can add an hour. I will probably say next time you can't add any more time. And my stream says for me it's 22 minutes, but I know I've been going since 13:30, so that's 14, 15, 16, 17, 18. So it's like 5.5 hours now. And the TTS is still up, I think. Well, let's actually... Well, I'm just checking I don't have several browsers up. So let's dare to open another tab, and this one is started. That's why I'm having it up still. Let's put these here too. Else I want to look at first. That one I don't know if I'm gonna watch. Tiberius one. Let's learn all the other stuff first, right? So let's put it there, something. Since it's a walkthrough of the room, I want to do... I don't want any hints. I want to learn things first. And this one... So... I think this seemed good. And this might be just a better version or a modern version. Doesn't mean that it's better. And this was the short one. That looked very nice. So let's see, now I dare to open a tab and search for this, right? Yeah, so I know what this means now. They changed in this ASM syntax to ATT. And there my 19 o'clock reminder of TryHackMe popped up. Yeah, so this is about the syntax problem. So that's how to set it then. If I had actually read it, I would have realized it once. So if we just search for ATT only here. ATT space, no. So that's not useful. Let's of course do syntax, right? Intel syntax and AT&T syntax. AT&T syntax is dominant in the Unix world. Since Unix was created, AT&T Bell Labs, there's a summary of the main differences. So, yeah. The order and the percent character. And parameter size. And L and Q and stuff. So numbers are suffixed with a letter indicating the size of the operands. Derived from the name of the register that is used, e.g. Imply. Yeah, we don't need this. With so Ghidra uses this. Nasm uses this, and I use both on Linux. Immediate values prefixed with, yeah. Register prefix with %. Automatically detect the type of the symbols. Effective addresses. Offset. Yeah, this is nicer. I like this. And I also like the order for Intel. So gas which originally used using this has supported both syntaxes on version 2.10. The Intel Syntax Directive corrects that ETD syntax for x86 is that x87 operands are reversed. Inherited bug from the original AT&T assembler. AT&T syntax is nearly universal to all architectures. Then it's general info. I guess it was before too, right? Keywords. So when I actually read it, I realized what it was. This also means we could probably do like something else here. ASM syntax equals what? Intel? So, let's put this in the notes. I did already copy it. Notes are still alive. And let's also do oops. So I'm in the wrong file. I'm just checking. So set AT&T syntax. So let's play with this. I'm also closing the notepad file. I found the general buffer overflow file here. Let's just put that link suggestion there, or the book suggestion. So we don't have to have another notepad open. Now let's hop over here again, and E. So, awesome syntax. Here's awesome bytes. Nothing. Yeah. Yeah, so now we know. It's Intel. The default is Intel. For some reason, the TryHackMe wanted to use AT&T. I guess it's a person who wrote that likes it. But now we know that the other one is Intel. So let's actually do AT&T capitals. It looks funny. I guess Intel should get a capital too, right? We have to be equal. So let's do E. This is like we started recently, right? So let's do AAA, IA. Let's do AFL. Let's do PDF. It's main. And let's now do EASM dot syntax, and I guess it was an equals ATT, and then we do the same thing. Oh, I missed. Just they're beside each other on the keyboard. So here we have push. Here we have push Q. Move Q, percent, and they're switched. So we can make it do whatever we want now. If we were to, for some odd reason, prefer the ATT one. So why have to want to keep track of these and do this manually when you don't have to? I'm like, this is nicer, right? Isn't it? Confirming that we can set it back and get the back, the nice. Oh, I've been sitting for too long. The nice looks of it. So we have added a command to our R2 nodes. Well, let's continue. So AFL. So list functions, yeah, and that's what we just did. I just wanted to confirm that I really had the same. Then the PDF at main. PDF very easy to remember, right? And I can't zoom this way, but we can view, zoom, and make it a bit bigger. So that's better, right? I guess you should get used to reading both. I'll just change how I sit. These cute arrows. So it's this one and then this one to here. Oh, that's so cute. We'll start by setting a breakpoint on JGE and the JMP instruction using the command. Yeah, which is the address of the instructions. We've added breakpoints to stop the execution of the program at those points so we can see the state of the program. Doing so will show the following. Oh, there are bees here now. Nice, 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 nice. Now we run DC to start execution of the program. The program will start execution and stop at the breakpoint. Let's examine what has happened before hitting the breakpoint. Let's actually add a breakpoint to ours, right? So DB, have to confirm the notes. So DB only will list breakpoints. We can use the name and we can use the address. And yeah, we also in one case had this kind of address here, right? But this is not an instruction. The first two lines are about pushing the frame pointer onto the stack and saving it. The next three lines are about assigning values 3 and 4 to local arguments variables. When it stores the value in the EAX. Let's look at ours, right? So DB. First, let's do DB. To confirm, we don't have anything there. And then we can do DB, and we can look here. So let's do DB on this one. So, and then we do DB. And we list it, and we have the breakpoint here. And then we have our commands. Tabbing in the wrong screen. To control the execution here, stepping back. We have all the things. So, to run it, tabbing in the wrong place again. So I really should look at mine. I'm just comparing it. So DC, and in the notes it says DC, continue execution. So if we do DC now, we hit a breakpoint that we just set. Just, yeah, double checking there. Oh, and then we do DS to get one instruction run. And when we do this, we could also look at the DR for the registers. So we run this one, RSP 10. Sub. Right. So maybe I should have put it here. Let's see where we're at now. So here's the instruction pointer. So it is this one. So to compare, this will move this here. That we won't see in the registers. We could look at the memory on this place. This is a test to see if we have what we need in our notes, if we need more things. PX memory address, we can look at this. And the memory address of var4h is this. So let's copy this. Let's do PX and paste the memory address, and we can look at this. And it looks very, very FFFFFF. So then we run another instruction with DS, right? Confirming DS, step 1 instruction. Then we look at this again, and it is still the same. So I don't even remember what program this is, what it does or anything. So I don't remember what line I was on. So I was on 56C. Yeah. So let's DR again. And now we're 56F. So 56F is here. So we looked at that one. Let's look at the other one. 10, right? I'm curious if this is correct. So DC is continue execution. We want DS. So that's what we did before. DS. We check this again. And let's just see. What did we really put there? We have a lot of things listed. So EDI. So it's definitely so RDI is here. It's definitely not FFFF. So I'm not sure if the commands work as they should, if I understand everything as it should. That looked a bit odd. Here's a program that echoes out your input, right? So we're supposed to give it input for it to be anything too. Right, I remember now. So we're supposed to give it input. So EDI. Right. Right, okay. So let's check EDI here now. So is this the last check we did? Yeah. So let's DR. RDI is still 1 there. So then we DS to step, and we'll look at DR again, and now we have another value here, and this, let's look at this address now. Right, so let's copy this, and I really should type PX. Do we want to print 262,000 lines? So we need a new, we need to limit it, right? Seriously. Am I like allergic to something? Bitches. I've taken allergy meds, but there was a new sort. New allergy pills. Oh. Whatever. So, I want to not print all of this, which is the default, but I want to print a tiny bit of it. So, we need to learn here. So, is there like a PX question mark? Because I want to know. Hex stump with comments. This is interesting. Show hex of a current function. So I want to see a dump, but not of that much. I want to limit it. Let's just test, right? So it doesn't say here to put an address. So it doesn't say that we're supposed to put, if we can put more information, like this 2 0x 004 006. This is hexadecimal. We don't want too much. Let's do 50, right? See what happens. It's still the same number, so I couldn't limit it. Yeah, I think playing with this is great. Do we have any test example output. So I usually, because I'm going to say yes, so I want to make sure I have notes of everything I want first. So help example, and this is like the base stuff. So in examples, let's put a few things here. Oh gosh. I'll just check the time of the box. 40 minutes, I think an hour. So this is where I first discovered the question mark. Feels like it was ages ago, but it was like 6 hours ago, right? Maybe not 6 hours ago. Maybe 6 hours ago. Yeah, so we want a test output of the AA. I'm just pasting this in the notes. I'm doing an SH on it. So, and I'm going to remove the AA here because it didn't do anything. And let's make it readable by just helping it a tiny bit here. So by the commands we make a new line there. So more help. Why not get the IA one? So this input or like whatever example will be kind of big, right? I'm not doing all of them. So we have parts of this already in the notes. Oh, almost said a bad word. There. Here we have the AFL. The AFL is nice. Let's scroll down to where I do AFL and then pipe it at once. So we can do them at the same time. So we could grab her, in other words. So and the colors is the reason we did a screenshot here. More commands, help, Then we found DR. And this is kind of boring, right? Yeah. Is this enough as an example output? I think we'll go with this, right? We can minimize this, and we have the help here, and we have the other stuff here. So on this one, maybe we should just put it all at the bottom, but the help is also like infinite. This is like more. I have the commands on the list. I can use this again. Let's press the Y button. So it will do this. Well, let's see if we can save some memory in this, right? So we don't need to have either running. So let's bye it. So is it all F? Yeah, so let's actually drag this up. So it's like at the top here. So I'm using my keyboard. Shift arrow up. So I don't remember what our goal address is here, but yes, Kuban. Okay. Yet it's not. So we're getting to something. So let's just go up. Oh, now we have zeros. Here's the program. Here. Here's a program that echo out your input. And this would be at the middle of this one. So six, 3, 0. Yeah. So why didn't it start there? I was like, I thought it would be here. No? But here we have 628 and there we have 638. So it should be in the middle of it. 630. This is where it should start. Because this address is what's in the register where it's saved. Let's go up there. Here, EDI. I'll go check what my kid wanted. I'll be back. så jag är typ sjuk idag. Nu är det klia på det för att jag känner mig vaken. Jag kände mig förkyld i arbetet. Jag har inte velat cykla mer idag. Och nu kände jag mig bara så här jättetrött och huvudvärk och så. Ja, det börjar klia också. Det är annoying. Jag vet inte vad det var i gott att det var allergi. Jag har bara ätit en sjättedel eller mindre av den där. So, yeah, so I'm not stressing now. It's it's getting late. I realized I have a bag with newly bought clothes beside me. Might I be allergic to that? I don't know. We'll see. Moved it a bit. I hope it's not that I'm sick in dishes because of that, because that's would be annoying, even more than being allergic to something. Right, so yes, we found this from looking at here, the address here. Yeah, here's the comment too, with a string in it, and also the address. So right, so this is the thing I would really like to, not to do pots, but to do print of. Right, so we need also something input when we run this to test with.
Aiden says,
Hey, are you following a course or something at the moment?
No, I'm just randomly looking. And also, as we're making notes for this, I've googled a lot and I found a few documents from old TryHackMe, well, Christmas stuff. So it's Advent of Cyber 2019 notes or hints here that we're checking and making sure I have everything currently in my notes here. So we've made most of this today. And there's also a lot of So many commands in here, and this is not all of them. This is just that I searched for P question mark and I got the P question mark. Then we can do PP question mark and we get a new list, you know, all of the things. This is PD question mark, and there are more question mark here for the PDS. We can do PDS question mark and get more on disassemble summary. So it's a very cool program. This is actually from R2 then. PDF main. We get disassemble the. This is kind of cool, and even a comment here about this string. So it's kind of cool, don't you think? And we'll look at the registers. We'll look at memory addresses.
Oh, cool. Yeah, 2 South African Rand is awesome once you know it.
Yeah, it's R2 is great. Yeah. So all the tools, you know, need to load all the tools. And also this is, are you sure you want to do 262,000 lines? Yes, I said. So here's the string. I really just wanted a bit around here, but I couldn't find out. I tried this to
2
limit
South
it.
African Rand law.
Translated from Tagalog.
Yeah, that's what it said.
I'll have to start calling the tool that.
Yeah, but I think then the actual name is shorter. Yeah, so I just realized that I mistyped here. So I'll have to try it again. Now it will jump down to the bottom of these lines, and I will never be able to find this place again, right? So if we do X here now, because I mistyped. Yeah, so it works! It works! I was just testing stuff. So we'll have to do more though, because it's, for some reason, it starts at 548 when we want 630, right? So let's do like 7 3. So that's still not enough, right? So yeah, why doesn't it do the actual things we ask for? Really, right? I'll do A here. So it doesn't at all do what I want now. This is interesting. So now it hopped to 1. So so what if we do like this? It's the same, meaning we don't have to shrink it down like that. And if I do like, what did I start with? Let's do 7 again. So, if you know the tool, please tell me what I should do, because I'm just guessing here. So when I did only a tiny bit, I'm still not getting the actual ones that I want. And when I increased it, it jumped earlier. What if I don't put this character? Now I'm thinking plus here. Now we get 1,000,000 lines again. Let's just say no to this. So it might just math it. Yeah, that's even more. I had to do the N. I couldn't just enter that. That would have been crazy. So it's actually doing math airline, not giving us. But it did work. It did work with the first one. We got just 2 lines. Here. And it's not removing this from this. That would be -20. Right. -20 is actually correct. Okay. Sure. I take your challenge. So there it says. So got it without getting a million lines. So why? It broke? It just gave me the same thing, which is okay. So what about px10? And then we do 20. And I did, well, let's do this one. So we have the real end here of it too. So it's really interesting, this. But if I do px question mark, there's really not anything more about this. Can I do px space question mark? No. So how do I get more information about the px? Print hexadecimal. There's also an F here. Zero AFOSWQ. Okay. So that's interesting. So this is what information I had, and that this works, right? But this doesn't seem to be correct. So it's actually like an offset from where we're currently at the prompt. So if we do like -1, wrong place. Let's do -4, right? Oh no, we have to do px -4. So now we get the address -4. Which is what? So oh my, that's not a 0. Yeah, just confirming that I wasn't like mistyping or anything. Yes, we're currently actually stepping through. So if we do ds again here, and we do dr, step 1, check the registers. So this we see here is always then the RIP. That's what we see. And let's also look at the PDF. I should have remembered that. That's me. My God, I shouldn't lean back like this. I can't type. And we see that we have our breakpoint up here, but currently we're at we're not anywhere. So when did we end up changing this? It was of course here that it hopped. So what if we do PDF and the current address 0x 0040040. Yeah. And then we do DS again. So it took us a bit to change this. Okie dokie. Okay, so well, that's a long number. Cannot find a function. I should have copied it. But I did type it correctly. So there is a DC. So what if we DC again, meaning continue execution? So it was still doing something there. So it was far, far away doing puts. And that we can't see then? So let's list the functions again. So AFL. So we were there at 4440. Did it ever use this one? Yeah, I'm kinda thinking it's time to switch. Well, actually, let's finish reading this one. Though I think we kinda have done. We did that. We didn't read this yet, but we did that. See. Oh yeah, they're like, this was logical, you know. And they have another program. Yeah, we don't have to look at that. They're doing the PX ones. Yeah, it would be fun to make a few programs with random instructions, you know, to see how it just behaves. So here we have another introduction here. Again with Radar 2. Again with D. And they say AA again, but this is 4 years old, right? So AA didn't do much. AA was better. Yeah, now it actually says for general help run ? That's nice. So I know that I just wasn't like finding the right help command. They're doing it too. I was just found it by mistake, or whatever you want to call it. Logic. Computer says done. EFL work main, we did this. Let's see if there's something new. PDF, printed disassembly function. And again, deal with memory manipulation using register. there are other cases to be considered. What? The parentheses here. And they possibly have multiplication in here. S. I read the instructions. Left bit shifting operator. I don't know if we have all this in the notes. That we just got from the other notes. Yeah. They're there. It's the same as the year before. Set a breakpoint, like last time. Running DC will execute the program until the breakpoint. So I've opened Advent of Cyber since I searched on TryHackMe for stuff. So we're not doing these, I'm just seeing if there's any interesting notes. They're just checking that stuff is changing in the registers. Oh, sheet in PDF format, and the OOD we already have it in our notes. And then they have the challenge. Oh my god, how long was this? Reverse elfineering. And then the bits of Christmas. Made with love. Let me see. Yeah, .net then. Okay. Yeah, so do I have these on any list? Right, let's check it out. So, I don't know what time it looks like I've been streaming, but I've been streaming since 13:30 my time. Because I don't have enough energy to do anything else anyway. Oh gosh. cool. Let's look at that. I haven't seen his image really. What's this? iOS is like. Burger bites. That hamburger looks a bit blue. Web app host flag, so that's some web stuff. Yeah, this one we already have up. There. So is this related or not? No, it's this is birth. So I'm thinking just put these links in the notes for now. It's a kind of file exploration. I have R2 here too. Or rather, that's where it is. So maybe it shouldn't be there. Maybe it should be here. This is a new thing I made. But this is also where I went. No, it's logical. Unote.net. Oh, must not start in a dot? Why? That's so annoying. .net then. How horrible. Can I start it with a space? It doesn't start with a dot, it starts with a space. Annoyed. So I know that these are just normal files. That's why there are limitations. So we had more. And then we have this one. I think it's the same text again, right? Is it exactly the same? Is it the same page? Because the other one had as a third, it was the Tiberius one. So this is, it's not the same, it's just the same. It's the same theory for a different task, I guess. No, but this is the same. Ah, whatever. So this is the one we're using to test, just to have a we're going to do that room too, right? We couldn't add more time, right? Because I've been doing this for a bit. And it's just been there in the background. Right, so this one, and then we have yeah, that one was the linked one, and this one was, when I searched here, I think I found something here. Right, it was a PDF, so I thought this sounded interesting. So this is not really exactly relevant, it just looked fun. So don't I have like... That was not a good drag thingy. Will I ever get here? So I've like, this is finished already. So these links, can I see the file dates? This is long ago. We can delete that one. This is the one we were just at. So I guess we'll do this one. So this one is a short one, but maybe I should really go to sleep instead. Let's actually do this a second. So it's just seeing who's online, and it's not correct. So I understand that it thinks I'm offline because stream crashed twice. But it says that Theo is online and he's not, so there's no one online because he's offline. And I'm not in the list. So hop over to DJ Clancy and tell him he has to make a like hacking and stuff category. Just checking here. Join the IRL Creator Club to get support, collaborate, and network with other IRL streamers. So, today we're Creator Clubs. So I guess it's for the DJ thing too, right? Whatever. Yeah. So there's no one. No one is dreaming. Not even I. I'm not streaming apparently. So. Buffer overflow examples, code execution by shellcode injection. And this one was a kind of like not a lot of text, hopefully a lot of knowledge. We'll see. And my throat is better, but I think it will TTS bits.
Buffer overflow examples, code execution by shellcode injection, protostar stack 5 permalink. Introduction permalink. Hey, I'm back with another buffer overflow article, and today we are going to do a really interesting exploit. Today we will finally escalate privileges using a vulnerable SUID binary. You can know more about that by reading the first buffer overflow article. I will also cover some interesting topics to fully understand this exploit. This is also the most realistic exploit so far. All the previous exploits wanted us to change a variable, execute a function. Stuff that are more like CTF, but this time we have a realistic situation. Without wasting more time, let's just jump right in. Read the previous articles first, if you haven't done yet.
So there are other articles there. So what if we look next? We get to the number 2. And this one is number 5. So sure. This is the one that... So we did want the shellcode injection one though. That's what was interesting. So 2 categories didn't really work. We just got a long list of hack the box write-ups, right? Well.
First of all, I'm writing this to help anyone who wants to learn about buffer overflow attacks. The basics to understand this can be confusing, and it took me some time to understand it myself, so I'll be covering some basics in this article. What I'm going to talk about is what is a buffer, what is a stack, and what are the memory addresses, and we will take a look at the application memory structure. What is a buffer overflow and why does it happen? Then I'll show a really basic and simple example for a buffer overflow. Protostar stack 0.
So sorry, I'm reading quietly. So if you disassemble the program and look at it, it will look like this. we know why they happen. Because we have a limited buffer and we use a program or something that doesn't limit the input. Segmentation fault. We get hello a. We don't see program exited normally. It happened because we entered 10 extra characters. They're using GDB that we did yesterday. So I was going to TTS the whole other thing, but I'm not TTSing this. I want to learn from it to do that. So GDB run. Yeah, so it's like I'm so amazed at the functionality of R2 now that GDP is like meh, right? Compared. So I'm thinking let's remove these from. It doesn't look good. I was just thinking that's a prompt, right? Yes, gubben. Ja, ska jag komma lite? Ja, jag gör mega slow motion och så kör jag TTS istället för att läsa och sådär. Jag tänkte jag orkar ändå inget annat vettigt så. Someone had just asked me if I'm streaming right now. I told them I don't feel up, so. Yeah. Because I don't have the energy to do anything else useful. So. Oh well. I'm thinking maybe I should get some dinner too. Oh. Missed letter. So what I just saw was that we can do run the program name. No, with parameters. So let's add this here. Right. Yeah, I know the breakpoints. Yeah. I should drink more of this. The input was A, which is less than 20 characters, so it's exited normally. Let's run input for more than 20 characters. Segmentation fault. So this is kind of the case we have here, but we're not running GDB now. And this one, but I'm kind of thinking we could. Let's see what a DC. So, what if we DC that? So I don't think it was at the start. So now it's thought that I don't know what commands, which I don't. I don't know what I'm doing. So let's quit this. And I control C by mistake. I was undoing in the notes, I thought. Right, so how do you run something here with arguments? Yeah, it's PID. It thinks I'm doing a PID there, probably, right? We did get a PDF download that we haven't looked at. So, this was a cheat sheet from one of the Christmas thingies then. Advent of Cybers. Okay. So, I need to check something. So, I'll probably order food for my mom. I'll just check to see that there are times for delivery tomorrow. Yep, there are. So that's the reason to stop this and do that instead. I could of course pause it, but yeah, actually I have a bit of a tummy ache too. But not from hunger. I feel just odd. Output of the command into line. Pipe to command. Pipe to file. So we know that some stuff works normally, you know. So yeah. Yeah. ODD. Okay, so we can do ODD and do it. Okay. Well, right, we could actually see what's wrong with my program this way too. The one we tested. Sorry, my tummy. It's starting to feel. So we'll see if I stream tomorrow. If I don't wanna. I wanna feel better, not all. No. So I would like to open the one I just closed, but it's not that important. I can scroll and I can open it again. Or we can just close both of these for now. So, this is not good. Bad so far. Bad notes on buffer overflow. No other answers. There. So I thought of that because of this, I guess. Because they're using both that and if you go to Kali, And this is 140 characters, so it's a bit tough to just generally. So if we remove one more. So I thought I was on the right number now. Maybe I didn't remember correctly. So now we're not at a lot of characters, right?
Dastiny56 says, best viewers on, web link.
Alright. So I'm like open Twitch. Oh my. Does it have to start stuff? Yeah, so I can't see any reasonable. I can't see any reasonable. Oh, sorry. Echo. So if I open my phone, I can do modding stuff on there. So how come it's more complicated like this, right? It's very stupid. So I can pin the message. I can reply to it. I can warn ban report. I can't like just delete the message. Why? Right? So I haven't never used this kind of thing. It's just annoying. I'll go back to, let's see here. Oh yeah. So I found a way to delete it there. I can do it from the stream manager. That's where I'm actually doing it usually, and on the phone too. but I never use it. Ooh, we have someone to raid. We have someone to raid. So that was kind of what I was going, right? I was going to check stuff. So this page doesn't work right now. Let's see. Yeah, I'm a bit tired. I'm a bit sick today. It's time. Tired. Oh my goodness. Echo, echo. So it's Thursday. It's Thursday. I didn't realize it's Thursday even. So, everybody. Let's see. I don't know if anyone is here. If anyone is here, we go into cyber insecurity. So, I'm sorry if I've been like a slow today, but. Oh. Oh, there's people there. That's nice. If you all the crashes today, I'm like amazed someone is here. So we had a lot of 2 crashes of stream today, almost at once. So thank you very much for being here, people, and see you tomorrow. Hopefully. Yeah. And I'm like, yeah, it's Thursday, right? Is there anything else to say? Yeah, I'll continue with the buffer overflow thing, definitely. And I'm learning things, even if it's not like an arrow to the goal. Oh, that's interesting. That's interesting. I'm learning all the things. And a bit slowly and I'm not reading as much and TTSing instead now. So, thank you everybody, bye bye. And check out cybersecurity stream.